Good morning, ladies and gentlemen. It is my great pleasure to welcome you here in Zadar. It's beautiful day. On behalf of the Croatian Chamber of Economy, County Chamber Varaždin, to the conference Rethinking Packages Fresh Look on the Plastic Sector and Advanced Materials for Circular Business Models. We have approximately 70 participants and most of them will follow us online. I would like to thank you all for your interest. Today's agenda will guide us from policies, innovation to practice and action. And we know that for company, especially for small and medium-sized enterprises, the main driving factor for sustainability transition is a regulatory framework. So this will be our first today's presentation. Policy and regulation such as Corporate Sustainable Reporting Directive is shaping the way businesses operate today, while networks and innovation ecosystem provide the support needed to put this principle into practices. Our project is dealing with network of digital innovation hubs, but today we will learn how collaboration between companies, researchers, and communities can drive sustainability using network of living labs. Next session, From Challenge to Success, will showcase inspiring real-life examples of innovation in circular plastic and advanced materials. And we will hear topics like transforming agro waste into biodegradable products, contribution of microsystem technology in packaging, and successful cases of turning plastic waste into designer panels. We will also present one new platform, B2 Green Hub, designed to deliver sustainable services to the business sector and strengthen the circular transition. In the afternoon session, we will have master classes which provide a deeper insight into extended producer responsibility, circular strategy for packaging, and innovation recyclability paradox in textile sector. Finally, we will conclude with a strategy dissemination lab featuring two panels. First is green transition in factories, and second one will be launching of the Circular Innovation Academy as a learning platform of this project. I wish you interesting day and inspiring day, and whether you are here in beautiful Zadar or online. Let me now welcome Agnieszka Wlodarczyk-Gebik, our project manager, to introduce Project Smart Circuit. Please, floor yours.
Okay, good morning. I was already introduced. In fact, I am Agnieszka Wlodarczyk-Gebik from Kraków Technology Park in Poland. And first of all, I would like very much thank you, Croatian Chamber of Commerce, Varaždin County Chamber, represented here by Renata and Božica, for organizing this conference in such a beautiful place with so much effort to shape it in this way as we plan it. So I will give you a short introduction to the project that join us today here in Zadar. So the project called Smart Circuit is about building the dots, strong innovation center between digital innovation hub, serving as one-stop shop for Central Europe manufacturing future. So why Smart Circuit and why digital innovation hubs? Already 5 years ago, established digital innovation hubs in Europe proved to be the most effective one-stop shops for driving digital transformation in our region in Central Europe. Basing on that, the next step of European Commission was to introduce digitally driven circular transformation of small and medium enterprises. And this unified our organization, I will represent in a minute, to join forces and concentrate on the most energy-consuming sectors as electronic, construction, and textile sector, and to introduce here the joint approach to support companies in this digitally driven circular transformation. As you can see on the slide, we are already 2.5 years behind. So the time was very, very intensive. And here today we want to present the achievements we delivered within our journey. So the project concept in a nutshell. Here you can see the countries we represent. We've got Poland, we've got Germany, Austria, Slovenia, Slovakia, Czech Republic, Croatia, of course, and Italy. And as said before, we aim to deliver services linked to digitally driven circular economic principle. The services that we are to introduce in our digital innovation hubs are tested within companies' ecosystem and shaped to the needs of small and medium enterprises. As you can see, our key action was focused on identifying and multi-stakeholders that can support us and who are very important in this journey. I mean that we are not only the project partners, but we are also being assisted by the representatives of regional authorities from our countries who are here with us, and I would like to thank you very much for joining us today, and also by the technical experts to advise us and consult the services that we, as the representations of digital innovation hubs, are going to introduce in coming days. The key action is to promote knowledge transfer and circular solution across Central Europe, look for the similarities, but also build on the things that we differ as country to country. Bridge territorial spaces with industrial, digital, and green strategies to move and introduce more sustainable manufacturing future. Who we are? Our consortium is a powerful alliance across Central Europe. As you could see countries, so there are 9 countries, but we represent the consortium of 12 leading organizations in the region. And here I would like to say that I'm very proud of this consortium and would like to thank you to each partner that through all this 2.5 years journey, with ups and downs, managed to provide the achievements I want to present to you. So who is with us? We have the Research Berglands from Austria, applied research organization that supports sustainable innovation and regional transition towards the circular economy models. We've got also the representative from Austria, the another one, Profactor, Industrial Research and Technology Center. From Germany, we've got 2 organizations, Fraunhofer Institute, the Public Research Institute, focusing on circular manufacturing solutions, and Microtech Southwest, Industry Cluster Association, focusing on micro and nanotechnology. From Italy, we've got SID Liguran Technological District, Integrated Intelligent Systems, Regional Innovation Cluster. We've got also the COMET from Friuli Venezia Giulia Manufacturing Engineering Cluster, focusing on mechanical engineering. From Hungary, we've got Pannon Business Network Association, Applied Research and Development and Training Center. And from, did I mention Slovenia? Not yet. So we've got TECOS. TECOS Slovenian Tool and Die Development Organization that also is the training center and R&D center. From, I'm just checking, from Slovakia, we got Technical University of Košice. And I'm looking. Oh, I missed Intemak from Czech Republic, Innovation and Research Center for Advanced Manufacturing, and neighboring Poland, so Kraków Technology Park. So what are our achievements? What we did in those 2.5 years, you may ask. We identified the curriculum for Circular Innovation Academy, the comprehensive training framework, equipping professionals with cutting-edge circular economy competences. It will be discussed today later on. We involve over 60 participants to test, but our aim is to reach the double number. We concentrated on circular transformation, industry future strategy lab solution, and that is what we will present you at the final conference in March. We also work through those 2 years to involve the policymakers in strategy dissemination labs, in design in each region meetings called Strat Labs to find the joint activities that with support of European digital hubs can be provided in our regions. We then concentrated on extending our competences, know-how, and ways of working from 16 to 28 European digital innovation hubs, also extending continent of Europe. And last but not least, we focus on testing the service portfolio that has been developed within the project in the real environment of the factories. So test before investment approach, that's what we did. And here, I see you can see it, everything. So the EU approach to achieving a circular economy, as you know, is guided by the more than two, but I would like to focus on two documents, European and acts, European Green Deal and the Circular Economy Action Plan, which aim to reduce waste, keep resource in use longer, and promote sustainable production and consumption. These legislative measures include the Waste Framework Directive, the Eco-Design for Sustainable Production, Products Regulation, Packaging and Packaging Waste Regulation, and Battery Regulation. All this, as you can see in our project, is focused on construction, ICT, electronic, textile, but we also look for more cross-sectoral sectors, providing here also the services. As said before, with Strat Lab town halls, we focus on capacity building, on barrier reducing, but working with close to the companies, we focus on pilots, testing the service portfolio being created within our network, coming to the industry future factory, how it should look like, what competences it requires, who can provide these services in our region, just to initiate the real digitally driven transformation. And on the left, as you can see and already introduced, there are the elements we use in our journey. Our approach, learning by doing, not a very practical approach, promoting real action to build capacity across the manufacturing ecosystems. We involve policymakers, research organization, business support organization, and work very closely with enterprises in workshops, but also one-to-one meetings and consultancy services. Within our project, the enterprises could see and touch the change, what really mean the circular transformation, what are the steps to take. When we look at the big picture, it is a huge challenge for small and medium enterprises to introduce the circular economy principle into life. We know what the challenge is, reality. But we are here to support them in this process, step by step, addressing their real needs and challenges. So within the project, companies directly experienced the advantages and were supported by the expert through the process, taking part in the events, taking benefits of the Circular Innovation Academy, of the courses, but also being part of the targeted pilot actions. Policymakers could gain strategic insight what is important for the companies and what challenges they meet on the way to introduce circular-driven transformation, and also what kind of instrument could support them within this transformation process. The organization, as we are, research and technology organization, share their knowledge. And last but not least, the test before investment prove why such approach is so important and that circular transformation can be introduced step by step. Action plan is our three-phase journey. First we define, then we prototype, and then we implement it. So what is listed here, in fact, majority of it was delivered within those 2.5 years of our hard work. So we deep dive into our ecosystem to see the similarities, but also see what differs us and how we can benefit from one organization to another, taking the best practices, best solutions, not reinvent the wheel, but also building and adding the additional value to the process. We integrated knowledge, but also built very strong ecosystem. Identified in our region over 100 great successful stories across construction, ICT, electronics, textile, and cross-sectoral initiatives. We, as said before, developed Circular Innovation Academy to match the competences that are needed in the future. We interview, we deep dive into discussion with companies, but also effectively spend time with discussion with policymakers. Then we came to the defining the service portfolio that can match the needs of enterprises and launch industrial pilots in real factory settings or real environment that supports companies in this transformation. You will hear about this later on. We engage our technological experts to support us in this process. We are in the process of training over 120 professional experts how to deal with digitally driven circular transformation. And the architecture that supported us within this process were 4 value chain workforces dedicated to each sector I mentioned before. But also to learn from each other, we participated in technology mobility missions. We developed 12 regional and we are in the process of developing one transnational strategic plan for the factory of the future. We demonstrated, tested before, and are in the process of expanding our network to 28 circular-inspired European digital innovation hubs, and I have to speed up a bit. Okay, so our impact by the numbers. You read quicker than I say. 122 success stories, 5 EU publications. It means that published on the European webpage dedicated to circular economy. Nearly 50,000 people reached, so people who came to see our Circular Innovation Academy, who followed our channel communication, looked into our social media, and were part of the conferences like that. The pioneering platform milestone presenting the knowledge collected within the network. And so far, already 60 recruited new ambassadors of the circular transformation coming from our regions, from different organizations. Our achievements, if you follow, and you are very much welcome, if you are not yet following, to introduce our webpage and see about the industry success stories, deep dive into Circular Innovation Academy, but also in the ways of working with our policymakers, from which we've got, as the partners, great support. Access to professional know-how, knowledge is power, and step by step, we are on the journey, and the process is not over. So far, we introduced 8 thematic modules, 58 training hours and self-studies. And on the right side, you can see what topics did we address. So fundamentals of digitally driven circular economy, the circular value chain in manufacturing, digital tools, IoT and technologies for circularity, focus on construction, focus on electronics, focus on textiles, transversal tools for digitally driven circularity, and learning by doing. So the master classes provided by our technological expert. And what I want to express here and underline that, of course, these courses are in English, but we are, as the consortium, discussing to take from it some lessons, individual lessons, and translate them to our local languages to really have the great impact. So later on in the panel, I will present the idea we are working on. So shaping circularity, industry voices for sustainable solutions, the voice they matters. So here you can see 12 regions, 62 interviews, 3 main sectors. Please go there, very inspiring stories, said from heart, but also expressing what the challenge is. Because there is a challenge, but that is why we are here. European Digital Innovation Hubs and organization linked to digital innovation hubs. Shaping circularity, policy perspectives for a sustainable future. We need to meet in the middle. To meet in the middle, we need to understand reality that is related to our ecosystem, but also to understand needs, expectations, and regulations. So 30 policymakers from our region express their perspective, share their worries, but also suggested how much and in which areas they can support us in this journey. My time is over. So already here you've got that is the sum up of what we did. 12 technology mobility missions in the process of establishing the network of 28 European Digital Innovation Hub, building the dialogue brokerage for long-term cooperation between policy and industry, testing in reality, in real life, catalog of services, and circular industry pilots being tested and introduced. The technology mobility missions, how they look like, so really see and touch, not time for drinking coffee. As you can see, a lot of great insights. How can we strengthen and upgrade the services that are provided by our European digital innovation hubs? Because each region created its own way to address the problems the companies bring. And here, there are 2 examples of the service portfolio tested and introduced. the Croatia Chamber of Commerce, they decided to introduce LCA analysis on their web page to support the companies with the first evaluation and verification of the stage the company is at. The service portfolio being tested and introduced by Kraków Technology Park in the construction. As you can see, we shaped them into much more, but here I put only the most important four services, categories of services, to end with being introduced by European Digital Innovation Hub led by Kraków Technology Park, that is called Hub for Industry, two services that are currently being tested and being offered to the companies, as is introduction of circular economy solutions and preparation for ESG reporting, and the audits, technology and circularly driven audits in the companies. And last but not least, I'm ending. I said already about our ambition to extend from 12 to 28 associated European digital innovation hubs. We call it in our project Circular Innovation and Development Corridors, and you can see the map. What our ambition is to go to Adriatic countries, Alpine countries, Baltic Sea, and Danube. And we are already in the process. So we addressed 8 centers outside our network. From 5 countries, from 7 NUTS regions, to create a unique models of cross-border cooperation in the field of digital innovation, combining regional competencies, sectoral specialization, and to shared vision of sustainable technological development in the heart of Europe. And here I've got some examples. So B2 Green Hub Network, it will be presented today. We've got the expert from the B2 Green Hub Network being represented by the project leader Pomorje Technology Park. We joined forces, and you can see that is what will be achieved in numbers being part of this network. We've also got newly recruited, newly invited to the cooperation Digital Innovation Hub for Eastern Slovenia region, from Western Slovenia, from Austria, from Styria and Vienna, from Germany, but also from the Czech Republic and Bosnia and Herzegovina. That is that here we already achieved 21 of 22 newly invited to the cooperation to the Circular Innovation and Development Corridor Network. You will listen to it later on, but here are the numbers about this industry pilots being implemented. 24 implemented pilots. Here are the great stories only of some of them. 55 companies involved. Please scan and check the implemented pilots. International conferences, it is our 5th one. We are meeting in March, and we'll present you our strategy plan for 2030. And follow us and stay with us. Thank you very much.
Good morning, everyone, on my behalf as well. My name is Božica Šantek from the Croatian Chamber of Economy, and I will be your moderator throughout the day and this conference. Firstly, I would like to thank our project leader, Agnieszka, for such thorough presentation of our project aims, results, and goals that we try to achieve to boost the stakeholders on their way towards circular economy goals. Let's hope it will be a successful journey and that we can cope with the challenges that are on our way still. Now let's get back to our agenda. In the first session on supporting policy, we will have an opportunity to take a closer look at the current policy frameworks and European initiatives that are shaping the circular transition, starting from sustainability reporting and due diligence to the very role of European networks and of living labs in implementing real-world circular solutions. For this, we have two distinguished speakers today joining us online, both bringing valuable perspectives from the European level. Firstly, I would like to welcome today Mr. Carlos Bravo Navarro from the European Chemical Industry Council, who represent the voice of European chemical companies here. He will guide us through the key elements of the Omnibus 1 directive proposal, focusing on how the different legal instruments interact to simplify legislation and improve the business environment. We also have here Mr. Navarro's messages that he shared with us, which says, in a moment where the European industrial sector is declining, the Omnibus 1 directive proposal of sustainability is a much needed opportunity to improve the business conditions for European businesses by simplifying existing legislation and cutting unnecessary costs and burdens, while preserving the core objectives of the green transition and the EU climate goals. Mr. Bravo Navarro, I hope you are with us. Could you please explain how the Omnibus 1 directive manages to balance simplification for businesses with the EU sustainability ambitions? Please, the floor is yours.
Thank you and good morning. I hope you can hear me.
Yes, perfectly.
Thanks. So thanks for your introduction. My name is Carlos Bravo Navarro. I work at CEFIC, as you said. CEFIC is the chemical industry council for European Union. We represent the chemical manufacturers in the EU. I work as a sustainable finance manager for almost 2 years now, and my role is to coordinate CEFIC's actions in 3 main files, which I will explain now. The 3 of them are related to sustainability, and the 3 of them are now being part of the Omnibus proposal. So if we can go to the next slide. Yeah, so first of all, I will introduce the Omnibus. I will then, to set a bit the scene, then I will explain the 3 files very briefly, so everyone has a grasp of what this legislation is. And then I will explain a bit the changes introduced by the Omnibus on 2 of the main files, and also give a quick state of play of the current status of the file in the legislative process, and then we can open the floor for questions. In the next slide. Yeah, so what is an omnibus? So an omnibus is a legal tool, a legal instrument that the Commission uses in many occasions. It's not the first time. Is a legal tool to amend existing legislation simultaneously. It doesn't mean an omnibus doesn't introduce new legislation. It just a text that amends, proposes changes to already existing laws. So this is why we call it an omnibus. That's the term. Now, the omnibus at which we are talking about today, this is the Omnibus 1 directive proposal on sustainability. This was the first omnibus presented by the Commission for simplification. Until now, I think there are already 6 or 7 more omnibuses in other topics. This first omnibus was published at the beginning of this year, on the 26th of February of 2025. And it covers 3 files. The Corporate Sustainability Reporting Directive, the CSRD, the Corporate Sustainability Due Diligence Directive, the CSRD or CSDD, and the EU Taxonomy. Now, what you see here in this slide is how this omnibus was adopted. It consisted of 3 texts. The first text was a directive to postpone the entry into force of the CSRD and postpone also the reporting obligations for certain companies in the scope of the CSRD. The second one, which you see highlighted in orange, is the main one. So it's the text that amends the key content provisions in the file. So this is the main text and the one which is being discussed now in the European Parliament. And the third one is amendments to the taxonomy delegated acts. This is very targeted amendments, but they are also important for the chemical industry, which I will explain also a bit into detail a bit later. So this is the omnibus what we will talk about today. I will now present the files and the changes so everything will make sense. If we go to the next slide. So first of all, the CSRD, the Corporate Sustainability Reporting Directive. What is the CSRD? So companies have been reporting on ESG information. ESG stands for environmental, social, and governance. So companies have been reporting on this data for decades now. We have some members that they have been reporting on ESG, on sustainability for almost 20 years. But companies did that in a non-harmonized way. So there were not a common set of rules and standards to report this information. So it was very difficult to compare the metrics that companies were reporting. What CSRD does is to harmonize these rules, so how companies report on ESG information. This is also a tool for the financial sector because investors also need information on how companies perform on sustainability topics, so they can take investment decisions on allocating green finance. So you can see here why was the CSRD. So as I said, to improve the availability and quality of the information, also to improve investment decision making, and it's also meant to be a risk management tool for companies because the reporting exercise is supposed to also allow companies to analyze themselves and see in which areas they are more prone to have risks and impacts on the environment and on and social topics. And the two main points from the CSRD that I would like to summarize would be the double materiality perspective is one of the main innovations introduced by the CSRD. Double materiality basically means that companies need to report on the risks that the environment has on the company. So from an outside-in perspective, but also there's a second perspective, which companies need to report on their impacts on the environment and society. So this is the innovation that companies they don't need only to report on the risks having a financial impact on them, but also on their impacts affecting the outside world. So this double perspective, it's called the double materiality, and it's one of the main innovations and one of the main pillars of the CSRD. And also the second pillar of the CSRD are the European Sustainability Reporting Standards, the ESRS. These are the specific data points, the specific disclosures that companies need to report on, that they are also being revised now. So that's for the CSRD. In the next slide, yeah, here the Corporate Sustainability Due Diligence Directive, the CSRD or the CSDDD. This is the CSRD harmonizes how companies need to identify and address actual and potential adverse impacts on human rights and the environment. It's basically how it sets behavior rules for companies on how they need to identify and address those impacts. And a second layer of obligation, companies need to adopt and put into effect a transition plan for climate change mitigation. That's the current text as it is now adopted, but this is being revised, of course. The purpose of the CSRD is basically to ensure that companies have sustainable corporate practices that are aligned with the transition towards a sustainable economy. And also in the same way as a CSRD is meant to be a risk management tool for companies, because the due diligence process should allow you to see where you are most exposed to environmental and human rights impacts. And how is this achieved? So basically, well, the due diligence process is quite complex, but summarizing, companies are required to map their chain of activities, their value chains, and then in those areas where risks are identified to be more severe and likely, you have to carry out a in-depth assessment. And then once you have those risks, those impacts identified, you have to prevent them if they have not happened. So if they are potential, or if they are actual adverse impacts, which they have happened, you have to mitigate them and bring them to an end. So depends on the nature of the impact. And then there are other obligations in the directive, such as stakeholder engagement, small reporting obligations. You also have enforcement, so companies can face penalties for infringement. So there's also a framework around these obligations. And lastly, the EU taxonomy. The official name of the taxonomy is the framework to facilitate sustainable investment. Taxonomy, the word taxonomy just means classification. It's the scientific term for classification. And taxonomy can be understood then as a classification system for environmentally sustainable economic activities. It's basically a list of economic activities, which if you comply with the conditions, then you can be considered as sustainable. The purpose of this tool, again, is to give guarantees to investors that if they are investing in a sustainable economic activity according to taxonomy, they can be certain that their capital is allocated towards sustainable activities. So it's kind of to create security for investors, and also for companies is to attract sustainable investment for their activities. And how is this done? Companies need to comply with a series of technical screening criteria, which are basically the conditions that an activity needs to comply with in order to be considered sustainable. So it's very summarized, and the conditions are in some cases very complex and quite difficult. So yeah, that's basically how companies do that. And then you also have reporting obligations, where you have to report your eligibility and alignment. It's quite a complex tool, and yeah, I will explain that a bit later as well. So that's for the legislations. I hope that was clear. And now I will start with the CSRD and what have been the changes introduced. I have highlighted two of the steps in the legislative process of the Omnibus. So first, I have summarized a bit the changes in the European Commission text, which was presented in February. And the second column, you see the changes as proposed by the European Parliament as of last 2 weeks ago. So several months have happened between the two columns, which in the second column we can see the negotiation, the outcome of the negotiations of the Parliament. So in terms of scope, the CSRD now, as it is the scope it is today, covers around I'd say around 40,000 companies. Then the Commission proposed to limit the scope to large companies with more than 1,000 employees, which with this limitation of the scope would mean that only 12,000 companies would be in scope. The Parliament even proposes a more drastic reduction of the scope by introducing an additional threshold of 450 million turnover. So that limits the scope to even more, to 6,000 companies. So in both cases, the scope is reduced, and in the Parliament, they go beyond the Commission proposal. In terms of assurance, this is audit provisions. The Commission proposes to delete the deadline, the requirement for having a reasonable assurance engagement. Reasonable assurance is the as to say that the deepest level of assurance there is. It's more expensive. It looks at more metrics. It looks all the process. So it's a more complex audit process. Whereas we have also limited assurance, where it's on a more superficial level of audit. So then the Commission proposes to delete the reasonable assurance engagement to save company costs, but also they delete the deadline to adopt the standards for limited assurance engagement, which is not it's not ideal, because this standard is supposed to give more certainty to companies. The Parliament also keeps this deletion, but they retain the current deadline for these standards, which is positive for businesses. On taxonomy, the Commission proposes to have simplified taxonomy rules for companies with less than 450 million turnover, but that's not completely useful for large companies, because these are the ones who are doing the taxonomy reporting. The Parliament then deletes the simplification measures, because of course, the thresholds are means that those companies don't need to report on taxonomy, so the Parliament deletes those measures. In CEFIC, we support the simplification measures as proposed by the Commission be extended to all companies, because, as I said, taxonomy reporting is a quite complex exercise, and these measures would be welcomed by large companies as well. On value chain, this is how companies request information from smaller business partners. The Commission proposes that large companies cannot request information from smaller companies that are outside the standards, and the Parliament keeps that position. That's kind of a safeguard for SMEs, basically. And on transition plans, that's a mistake. Actually, the CSRD doesn't change the transition plan provisions in the CSRD. Apologies for that. And lastly, on the reporting standards, both positions introduce a kind of a principles to simplify the standards. The standards were adopted in 2023, and large companies have already reported according to the first set of standards, which are now being revised also by to simplify them. So both positions include principles for simplification. That's for the CSRD. Also, next slide. Very quickly in other developments. So as I said, there was also this stop the clock directive, which postponed the entry into force and the reporting obligations for certain companies. There was also a quick fix for the standards, because the standards introduce some phased-in disclosures, and of course, if some companies then don't need to report anymore according to the CSRD, this quick fix just postpones some data points in order to align it with the stop the clock directive, and also, as I said, the taxonomy amendments from July. From the taxonomy amendments, I would just highlight a deletion of a paragraph in Appendix C, which is the DNSH criteria for pollution, which required companies to carry out a very large assessment of non-harmonized substances, which was very burdensome and not fit for purpose. And CEFIC advocated a lot to delete this paragraph, this data point, and now it has been deleted, so it's a positive change for businesses. And now I will move to the CSRD in the next slide. So the Commission keeps the scope of the CSRD, which is companies with more than 1,000 employees and 450 million turnover, whereas the Parliament significantly increases the scope with companies with more than 5,000 employees and 1.5 billion turnover. So it's a significant both scopes, according to the Parliament, would not be aligned. On the value chain approach, this was one of the most contentious and sensitive topics in the negotiations. The Commission proposes a three-step approach where companies need to first map all their value chain, then carry out an in-depth assessment of, but only limited to direct business partners. So you see here Tier 1 business partners, and only go beyond Tier 1 business partners if the company has plausible information that impacts are happening beyond direct business partners. The Parliament simplifies this three-step approach and adopts a two-step approach, where first you need to do a scoping exercise. This is not the same as a mapping. Scoping also has some risk factors incorporated, so you don't need to map all your value chain, just these areas where you believe are more risky, and then carry out further assessment. Companies can prioritize direct business partners, but that's up to them. And also if you have information. So it's kind of a combination of the step 2 and 3 of the Commission proposal, but this is more simplified and yeah, it's more straightforward. On transition plans, this has been probably the most sensitive topic of the negotiations. This has been discussed by all the groups in the European Parliament. The Commission only changes the put into effect, which is basically implementing. They change it to adopt implementing actions, which is not very clear what that means. And from CEFIC, we didn't see that change as significant. Instead, the Parliament proposes several amendments, so delete to these adopting implemented actions, so companies only need to adopt the transition plan. They also replaced best efforts by reasonable efforts, which is a lower legal threshold. And more importantly, they also delete the reference to the 1.5 objective in the Paris Agreement, which was, according to our members, is a source of, it risks bringing litigation to companies, as we have seen already in the Netherlands with Shell and with France as well, with some companies. So the deletion of the 1.5 alignment with the Paris Agreement. And lastly, the civil liability. So the CSRD foresees that companies that cause damages by infringing the directive, they can be held, they can be liable. What the Commission proposes is to partially delete this framework, and especially what I would like to highlight here are 2 points. So the access to justice conditions for trade unions and NGOs, which was a source of concern for CEFIC members, because that would mean that natural or legal persons that have not been damaged by the company, but other parties could put forward claims on behalf of these entities, and also the deletion of the overriding mandatory application of the EU law. That meant that EU companies could be sued abroad for events happen abroad. So that, of course, also opened the door to a lot of litigation from outside of the EU, which could be misused from other entities. And the Parliament also proposes to keep this partial deletion. So those are the changes. As this is quite technical, so please feel free to raise any questions afterwards. And now I will quickly summarize the state of play, because the omnibus it's been quite rocky, difficult process. So what I would like to summarize here is that 2 weeks ago, the rapporteur, which is the leading MEP that leads the negotiations, he proposed 2 compromises. One compromise was meant to have the support of center-right and far-right parties, so it watered down significantly the provisions in both files. And the second compromise aimed to have the support of the center and center-left parties. So these are the traditional groups in the Parliament, so the Renew and S&D, the Socialists. After quite some tensions, in the Committee of Legal Affairs, which is this file, which is the committee where the file is being negotiated. The compromise 2 with the traditional groups was successful, and it was adopted in committee. So yeah, that was the first step. But then that text had to go to the plenary session in the Parliament, which was the following week. And as we can see here, the text in the plenary was rejected because for the far-right parties, the text didn't go far enough in helping businesses. And for left and far-left parties, the text went too far in deleting safeguards for the environment and human rights. So the text was rejected, which was a bit unexpected. That was last week. And what that means now is that the text will be voted in the next plenary session of the Parliament next month in November, so in a couple of weeks. And there's a new deadline for amendments, which is the 5th of November. So yeah, this is basically a state of play. And I think in the next slide, I also put a bit the general timeline of the file. Yeah. So here we are now in the orange flag, about to finish the first stage of the negotiations where Council and Parliament find their positions. And once Parliament adopts their position, we will enter the trilogues. Trilogues are these negotiations, these joint negotiations between Parliament and Council with the supervision of the European Commission. And once the trilogues are over, the text will need to be adopted again in the Parliament plenary. And we expect the adoption in the first quarter of next year, hopefully, if it's not delayed anymore, which we hope it's not further delayed. So this is where we are now with the omnibus, and I think that's all on my side. I think I stayed to the allocated time. Yeah. So thanks for that. I hope. I mean, happy to take any questions if there are any, and I hope this was useful. And I think I can. If you need the slides, I think they can provide them to you as well. Thanks.
Yes, thank you very much, Mr. Navarro Carlos, for sharing your valuable insight and state of the play on the EU sustainable policy landscape. I believe we can afford a question or two if we have from the audience here or from the participants. No, I just want to remind the attendees who are following us on the Zoom platform that we have open question and answers and chat for you, so you can ask a question there and we will be happy to provide the answers later on. Thank you very much once again. Now, if you agree, I would like to continue with the supporting policy session with Mrs. Martina De Sol, who is a director of the European Network of Living Labs and who is also joining us online from Brussels. ENO is one of the leading organizations empowering global developing of living labs. Mrs. De Sol will talk about how Living Labs as open innovation ecosystem can help transform sustainability goals into practical and circular solution. Please, if you are with us, Ms. De Sol, welcome, and the floor is yours.
Good morning. Thank you very much for the invitation. I hope you hear me well. Yes. Can I get control of the slides because I would like to go fast on certain parts? Is it possible? Yes. Okay, good. So first of all, I'm really happy to be invited here by Agnieszka, our council member, really to bring the vision of Living Labs as a bit complementary and maybe a next steps for the digital innovation hubs. ENOL is the International Non-Profit Association of Certified Living Labs. In the past 20 years, we have been promoting the Living Lab concept is supporting also especially EU policies, but lately we are working a lot with the United Nations as well to enhance living labs and their sustainability and helping setting up living labs that are according to our values and visions. It's the European Network of Living Labs, but it's a very global network. We are present in 5 continents and 38 countries, and we have now already 184 members. We certify Living Labs to make sure that they are using the principle with integrity, especially when using the methodologies to involve the citizens, because our motto is really to empower everyone to innovate. We are providing a lot of capacity building activities for existing living labs, but also to set up living labs. And we are organized in many different working groups that are going deep into specific thematics. Very quickly, we are really also very present all around the world to promote the approach and the movement. So just to say that Living Labs in the past couple of years are actually gaining again a lot of traction after 20 years, especially because the European Commission has decided to really use Living Labs as the way to involve all the possible stakeholders in the proper way to test and to democratize innovation, but also to help companies to de-risk innovation. The biggest, let's say, recognition it has been in the missions, in the EU missions you probably are familiar with, especially with A Soil Deal for Europe, where the Commission decided that the Living Lab would have been the way to implement the mission and to achieve its results by the creation of 100 living labs and lighthouses to get a healthy soil by 2050, but let's say towards at least in 2030. And then all is coordinating the supporting structure that is going to assist all these 100 living labs. But of course, when we are talking about a way to involve all the stakeholders, but especially citizens and users, or who is going really to experiment with the innovation, we are talking about living labs, and the Commission lately is really in many topics of Horizon Europe also mentioning living labs that follow a null definition. And now we are going to see why. Another important thing is when we talk about living labs, we are not only talking about experimenting with technologies. There is a huge, let's say, basics, a building block on social innovation, because focusing on people, citizen-oriented strategies will help also the inclusion, will help social innovation, inclusion, engagement, co-creation, and collaboration. And this is particularly important when we are dealing with the digital transition, because everyone should be on board, because we are having, of course, the future users of the technology we are testing tomorrow. But of course, another core activity is the industrial demonstration, meaning that we can really experiment and industry can use this also in the pre-market experimentation, the test before invest that was mentioned before, also with new technologies and things that are really not yet regulated. And of course, open science, because most of the findings are working actually in an open science approach, because of course we are talking about open innovation activities where the knowledge can and should be reused by everybody. So what is the null definition of living labs? According to all the experts in null, living labs are open innovation ecosystems that act in a real life environment and are based on a systemic user co-creation approach that is integrating research and innovation in communities, placing citizens at the center of innovation. So from the point of view of all, living labs are organizations, are not projects, are organizations that operate as intermediary orchestrators among citizen research organizations, companies, and government, covering all the stakeholders to create joint value co-creation while rapid prototyping, scaling up innovation and businesses. And what is important is that this involvement is iterative, meaning that especially when it comes to the end users, we don't involve them only at the very end of the experimentation, but we try really to do it along the value chain. And this is where it is particularly important also for the policymakers, because we are having insights also on what can be the problems arising also for the regulatory side, while testing from a very, very early stage with the real people. So as we said, we are talking about open innovation ecosystems. So it is the sweet spot between open innovation, but also user-driven innovation. Living labs are using both. And this is very important because it is a way to stay relevant having always the opportunity to be contaminated by new ideas. And the peculiarity also, considering what maybe other digital innovation hubs or test beds are doing, is that they are experimenting in a real life environment. So if we are thinking about a city, this is not a living lab. It's going to be a living lab only when we will have, oops, sorry, it's not working. Okay, when we have all the different the different stakeholders involved, but also, of course, the technology. By involving everyone, we will have the feedback of everybody. We will have an early buy-in also of the new technologies. And it is important that when we are involving the stakeholders, it is clear that there should be something for them in it for all of them. So for the research community, for example, is going to be to have data, publications, insights on how the technology is working in a real life environment. For industry, it is early experimentation, there is key on innovation, really see what are let's say the preferences of the future clients. For society is to be involved in the innovation, and so understanding more and be part of the change. But for government, we say living labs are particularly relevant for regulatory learning. So to support the government and so the public administration and the policymaker in getting insights that we support evidence-based policies by identifying possible gaps in policy regulations or, let's say, needs for a specific regulation on sectors that can arise only when we are testing in a real-life environment. What is important is that when we are involving all these different stakeholders, it's not that we work for the benefit only of one of these stakeholders, but everyone will get their own part of joint value co-creation. As we saw before, one of the most used methodology is the design thinking. And as you can see here, what is really important is that living labs with all their actors are starting working already in the problem space, not only in the solution and in the deployment, but also to understand which could be the problems in adopting a specific technology, a specific product, and this will help to iterate this cycle of testing with all the users until we can move to the second step. So from the problem to the solution to the deployment. And this is working not only on the testing of the technology, but it is working also on the testing of policies to really understand how we can support the policymakers. Living labs started, let's say, in the 90s, especially with ICT technologies moving to health, urban, rural, culture. Let's say that in this very moment, soil and agro systems are really under the radar, but in the past couple of years, we see that there is adoption of living labs also for climate, water, tourism, education, and a lot also on mobility. What we always say is that living labs work because their role of orchestrator, it means that they are trust brokers, meaning that they are in the ecosystem, they are trusted by all the actors, and they learn from one another, and so learning by from each other, it means that we can have trusted data and trusted feedback on what we are actually achieving. And building trust takes time and real interest. That's why we say that we cannot use living labs for every type of experimentation, but only when we are dealing with the complex, wicked problem. And also, living labs are bringing change. But while experimenting, it's not that we are only changing the society, but we as living labs, we need to be ready to change according to the feedback that we receive. There has been an experimentation a few years back with 89 different companies and startups that use living labs. And let's say that only 50% arrived to the market, with 25% that really decided to abort their possible product on the market, but the other 25% managed to reboot and reorient the innovation. So it is really a way also to make it quicker to the market. As we said, for us, Living Labs are not projects, but are really the organization that are dealing with multiple projects and are there also when there are no projects to cover their work, but they keep on working with the ecosystem. They are present, they change the ecosystem. So as we said, they are working in a real life environment. This is why they are de-risking innovation, because they transform clients into developers and they really support the creation of new products and services. And by addressing complex societal challenges, what we call wicked problems, they really help to bridge the gap between research and market, and also to create a new impactful innovation, because we have insights in what can go wrong. And by involving the end users in innovation processes, we develop products and processes that are tailored to the needs of the society, and we are getting insights into the adoption. So this is very much important when we are talking about the circularity and sustainability of innovation in the long run, because we co-design how they are going to work along the value chain, but also after they will be actually adopted. And last but not least, by involving all the different actors, so the quadruple helix or the 4P, so public, private, people partnership, we are having a faster innovation cycle, because this is a rapid iteration and prototyping that can make you also fail faster, but fail better. So why this matters for circular economy? Because when we are talking about real world experimentation, is really helping to reflect on how people will actually use and dispose, in this case, of packaging, how logistics work, how infrastructures support the circularity, but also it means working across the value chain, bringing together designers, producers, retailers, waste managers, policymakers and consumers, and of course researchers, and really the company that are really developing the innovation. And this is really a collaborative platform that can really help to break the silos and to understand what is really essential for scaling. We are talking about user-centered innovation, and this means that the products that we're going to develop are aligning with the user's needs, but also taste, and this is really helping us to understand what is motivating the consumers to use in our case, the packaging or any other technology or product. And of course, this will also help in communicating how the products are developed to avoid a big market phase. I remember 20 years ago, there was the big boom of nanotechnologies, for example, but this has not been communicated well. So there was a moment where, for example, all cosmetics were claiming that they had nanoparticles or they were very effective because of this, but consumers got very scared. They have not been involved in the process of understanding how this is going to impact. And of course, this has been even took off the market, or the communication has been drastically reoriented. Another important thing is that Living Labs can be considered also as research infrastructures, because they collect data, they experiment, and they collect data on environmental, economic, social impacts, but also, of course, on the effectiveness of the technology. And this is very important because they support also evidence for policymakers, but also for investors to support policies that will actually facilitate the adoption of certain products, but also investors that want to invest in specific lines, and also can support the measuring of the outcomes that that are really dealing with the circularity, like waste reduction, CO2 savings, how we are really supporting the overall policies by experimenting. And last but not least, let's say that living labs are used also as regulatory learning tools, meaning that moving from a test bed to a living lab, so bringing the research out of the research institution, out of the lab and into the streets, the homes, it is really supporting the kind of identifying which could be the real issues that can be faced and that need to be regulated. We had the very first living lab hosted by a public research center, that it was the Joint Research Center by the European Commission, a living lab on mobility that helped in shaping, for example, the policies around automatic driving, so the cars without the drivers, finding things that in an environment that was not a real life environment was really not spotted before. And this is particularly useful with all type of emerging technologies where there is no policies of reference. As an example, I would like also to bring two of our members. One is CM Barry, that is dealing with agriculture, agri-food, and also the reuse and the circular reuse of agricultural products and wastes. They've just launched a project that is called Win Organic, that is really working to support the establishment of a all holistic sustainability framework and tools that goes until the policies, and is focusing really on packaging and really from the pilot scale to the validation, involving the policymaker in all steps from the identification of the problem to the solution to the value proposition. So we hope to be able to share good results around this. And last but not least, I would like to bring the example of the city of Amsterdam that decided to become a circular city and has based this change around really the creation of an urban living lab that has been in the past 10 years experimenting and testing and developing all urban solutions in the reality, linked to on how circular and how was the impact of circular technology into the overall city. And this brought also to the signing of a manifesto that apparently has spread among many different cities around Europe. So I hope I am well in time, but I'm here, of course, for answering your question if there are any.
Thank you very much, Mrs. De Sol, for this very clear and very well illustrated presentation with the clear examples on how collaboration and experimentation drive sustainability in practice. I hope our policy stakeholders who are here with us and online are listening very carefully, and I hope they will find a way to follow your steps and your manifest. Do we have any questions maybe? Not for now. As I mentioned before, we can provide answers later on. So if there will be any questions, we will get back to you later on. Thank you very much once again. Yeah, thank you. Moving to next session, now we will go forward to the title called From the Challenge to Success, Innovative Projects in Circular Plastic and Advanced Material. Here we have some inspiring examples on how circular way of thinking can turn challenges that companies across Europe face all the way into real business opportunity. In this session, we will have 5 carefully selected speakers, each of whom will have a short presentation showcasing innovative approaches in circular plastic and advanced materials. And first, here I would like to welcome Dr. Vesna Žepić-Bogataj, who is here with us and will present how to transfer agro waste on biodegradable products. The title of the presentation, Circular by Nature, Transforming Agro Waste into Biodegradable Products. Dr. Žepić-Bogataj, the floor is yours.
Thank you very much for the kind introduction. So welcome from my side. I am coming from Slovenia, from Tekos Center. So yeah, today I'm very happy to be here with you and maybe to join some inspiring, hopefully, success stories that we had in the previous 10 years. So we kind of start with this circular economy projects in 2015. And yeah, with some of them, we kind of break through quite a success. We are an R&D center, but we are very much involved in industry, so in a plastic processing sector at most. So we are in daily contact with industry, with companies. So we know their challenges and maybe their wishes how to become more greener in branding. So yeah, once a vision, and now it is kind of a competitive advantage, I would say, to be circular, to be green. So of course, to be from a linear perspective to the circular loops. So this is one of our first projects. I am presenting all the projects with international background. So these were European projects with partners from European EU members. So the first one was how to use the banana waste from new products in different kind of sectors. So from aquaculture to the plastic sectors. So the idea was from Canarian Island because they were facing with a lot of pseudo banana stems from the banana plantations. So they had a waste, a big amount of these wastes accumulated on the floor. And they think of idea how this could be maybe converted into some good raw materials for the new loop of the products. So in that perspective, we join our forces with them and try to incorporate the banana fibers to the plastic polymers, so to get the new materials, the new family of the composites for the plastic products. In this specific, we were working on the injection molded products. So it's so-called bio-based materials, so combined with technical polymers and biodegradable polymers. And with that perspective, we did some examples for the water sector appliances and also for the automotive. And on another way, we use this antioxidant extracted from banana pseudostems for the fish feeds. Dietary fish food was based on this antioxidant extract from the banana waste stems. And we also integrate these new plastic materials for the sleeves, for the covering of the bananas in the plantation itself. So it became a circular loop, I can say. So these new protective biofilms contain the fibers from their waste residues. And this was, of course, a protection against the insects. And in the last picture, yeah, here you can see that we produce the new bio-based plastic products, as I was saying, for the automotive, electrical industries, and also some white goods sectors. The next one was also the project developed along the life environmental program, sorry. And this was the citrus pack, okay? So the core problem was again from Spain, plantation of citruses, of citrus fruits, so mandarins, lemons, and oranges. And actually the idea was born in IMC Innova. So this is the company that are producing the juices, the fresh juices from oranges. And of course, with this process, they had a lot of waste. So on the yearly basis, they have like 60,000 tons of orange wastes, 20,000 tons per year of the clementine wastes and lemon wastes. So this is really a lot just with one company. So you can imagine the multiply effects on the vast perspective of the orange or citrus developers and plantation growers. So they kind of projected solutions that this waste could be maybe transformed into another interesting products that could be maybe used with another sector perspectives. So we kind of extract the antioxidant powder from the citrus peels. And of course fibers for the plastic-based materials. So you can see here which two ingredients we used, and we kind of transform it from the pure waste to the another intermediate materials. So the first one was antioxidant powder, and the second one bioplastic materials, so PLA combined with waste citrus fibers. And with these materials we developed new plastic bottles for the fresh juice on the first pictures, and on the second new cosmetic packaging also with citrus fibers and PLA composites. And in the very innovative way of how we can maybe use this antioxidant powder, we use it in the cosmetic products. So this was done by a Greek company, Olvetia, who is a company developing organic cosmetic products. So they incorporate this antioxidant powder into the creams and the peeling serums for the face. And this is the three products that were developed from this project. And the next one that I want to show you is the one coordinated by a Slovenian home brewing institute. Because in Slovenia, I think it is now the third in European level. Slovenia is on the third place of the hop brewing sector, and fifth in the world according to the hop producers. So in that perspective, they are using the PP plastic strings for the hop growing industry. And if you can imagine this PP string all together with green hop plant, it is not very usable for recycling, because we have on one side really biomass green material, and on the other side pure plastic that is not biodegradable. So we kind of think that maybe we could replace this PP string with more green alternatives, so biodegradable one. And we developed a project together with multiple European partners. And we kind of use this waste in the transformation and, of course, valorization for the new intermediate materials. In one loop, no, it's not seeing on the screen. So yeah, in one loop, so we are using the hop fiber material from this green agro waste. And of course, on the other side, we are doing the compost. So this one, the green hop plant with the bio-based or biodegradable twine. So at the bottom of line, we can use, of course, the green milled material for the new brand of materials based on the bioplastic, and on the other hand, the pure home composting waste. So we are having the two major group of the materials. So for the valorization with the hop fiber materials, we of course modify the hop fibers itself at a company in Germany, and then we also transform it into the dried hop fibers as a reinforcement for bioplastic composites. In that perspective, we are doing the extrusion step at first to get bioplastic pellets, and this was then subsequently processed by injection molding for the bioplanting pots that you can see here. And these bioplanting pots were then used for the hop growing plants. So it all became a circular loop in that perspective. But with pure modified hopper, we also intact the packaging sector with the pulp molding process, so to do the packaging cases for the wine bottles. You can see it on the next slide, a few examples of how we did that. And these are the end products that are now in use and already on the market. So the first one, biodegradable twine, which is now used by at least Slovenian hop growers that are in our nearby. I know that they are using this string instead of polypropylene, which is quite a success. And then we are producing also these planting pots, especially for this institute, so to have them equipped for the new plants and the new sorts of the hops as well. And the Czech company Tridas, that they are developing packaging which is totally biodegradable. It is for the packing of the maybe some more premium wines, I would say. And then the last one, this is the new project. It will be it will be finished by the end of this year. It's only a 2-year project. This is not an international, I would say, but Slovenian local projects that we are developing together with mill company Katic. So he kind of developed a pilot line for the protein production from the legumes. And with this process, he has a lot of starch residues that is accumulating at their company, so they have nothing to do with them with this large amount of residues. They have to move it to the landfill in some smaller amount they are using for the feedstock. Okay, but we kind of think about maybe some really new perspective how we want to maybe use this type of, I would not say wastes, but maybe byproducts or residues. So we kind of try to combine it with different kind of polymers, biopolymers, who has all of the certification for biodegradability. So with polylactic acid, PBS, and then also the legume wastes, and we combine these 4 ingredients in the extrusion process to get out the biocomposite pellets. Of course, the output material was characterized according to the toxicity, biodegradability, and of course processability. And we also tested in the perspective of the mechanical properties. But our target product was the chewing bones for dogs. Okay, this is a kind of a toy, not for eating, but for playing. Because in any perspective, it is still based on the bioplastic, so it is not really good to be digested. But for the chewing, for the dental activities, it is the application. It is okay. So we are now in the phase of testing in the second trial, of course, with dogs. So we developed a different kind of formulations with different amounts of this starch inside. So we upgrade the material formulations also up to 50% of starch inside. And the more of the starch was added in the chewing bones, the more was the more interesting become from the dog perspective, because the smell was really higher, and they want to chew it to the middle fractions. And this is some of our testers. You can see it on the pictures. So we are now in the phase of the final market wrap-up, I would say. So we find a kind of a winning combination, and we just got the report for the toxicity and the biodegradability, and it is confirmed. So it is now safe in the toxicity perspective, and also it is ready to get the biodegradable certificate for it. So we are happy to get that results. And this is now in the commercialization phase, when the project will be finishing by the end of this year. So this is the kind of end products that we want to have it on the stores. This is in a very, very briefly way, I think the last slide. Yeah, so thank you very much for your kind attention. I will leave the presentation to the organizers, so you can get it if you want. But I am here on this email. If you have any kind of questions, I'm available. Thank you.
Thank you very much. Thank you very much, Dr. Žepić-Bogataj, for sharing this presentation and these inspiring projects with us. We heard so many examples on how to transfer agro waste and bioproducts into new usable ones. So if you have maybe any questions for Dr. Žepić-Bogataj, if not, yes. Here's coming the microphone.
I'm just curious, how long does it take you from the designing the product to commercialization phase with getting certification?
Just approximately 2 to 3 years, because yeah, from the scrap idea to the final products, yeah, all of these projects that I was just presenting were 3 years at least, except the last one was 2 years. So yeah, 2 to 3. Thank you.
We still have time.
Not
Sure.
Sure.
I'd like to ask about the end of life of those products, especially the composite ones or the PLA-based ones. And if you have some metrics like environmental impact metrics, because quite often from life cycle assessment, these materials come out much worse than the raw oil plastics. So I'm just trying to figure out some comparison if you have some.
Thank you very much. Yeah, we with all of these projects, we did the LCA analysis as well. So in that perspective, we always developing PLA-based organic materials, because we want to have it at the end, the certificate for industrial composting. So this is the end waste. It is not the burning or the, I don't know, landfilling or something, but biodegradability, industrial composting. But when comparing this with synthetic plastic, of course, the solution is better. But you have to realize that these intermediate processing steps, so drying, processing, extrusion, injection, it all involves not so much on the life cycle assessment, but on the life costing cycle assessment. It has a definite larger impact than the technical plastics, for sure. I hope I answered you more or less what you were interested in.
Thank you very much for your questions. Somebody mentioned time. I believe we are running a bit late behind the schedule. I would not like to cut anyone short, but I would kindly ask the following speakers to stick to their allotted time. Having that in mind, I would go to our next speaker, Dr. Kerstin Glaser, who is with us from Germany, from Hans Schickert Institute, which researches and develops within the field of microsystem technology. Her presentation is titled A Possible Contribution of Microsystem Technology in Packaging. And we also have Dr. Glaser statement which says that it is always exciting to discover new challenges and solve them in interdisciplinary teams. Is it the sentence that you have shared with us, right? So can you tell us a little bit more on how it works, starting from idea to the final product in your teams? Please, the floor is yours, Dr. Glaser.
Thank you. I hope you can hear me quite well. So my name is Kerstin Glaser. Thank you for the possibility to give this talk here and to show you a possible contribution of microsystem technology to packaging. So I'm from Hans Schickert. We are a research institute in the southwest of Germany. We have 4 sites with around about 260 employees, and we work in the field of microsystem technology. Here you can see our business areas. As a research institute, we do our basic research in the field of researching, but we also try to transfer our results into the industry by developing in a close cooperation with the industry. And we have also the possibility to manufacture small and medium sizes, so we can close the gap of the products on their way into the market. Venturing is the last business area where we also have the possibility to bring our IP into industrial applications. As mentioned before, I'm from the field of microsystem technology, and here we work with the packaging technology, mainly with focus on electronic packaging. That means you can see here some of our core competences. We always work on technologies and process chains to integrate functionals. Here you can see, for example, a 3D circuit carrier, mainly done by injection molding and functionalized by printing technology, for example. But we also use this technology for the integration of sensors. Here we work with commercial sensors, but also with developed sensors we do on our own on the basis of physical principles. And this we use to bring the sensors in the place where the signal appears. We work also with rapid manufacturing and digital processes. Here the focus is on individualized products. That means this should be commercial from lot size 1. And the last one I want to show is the system in foil, because here we work with foils of different materials, and we want to integrate the intelligent system by using thinned silicon chips. So the technologies we use to integrate the different functions are quite sustainable technologies because they are all additive processes, and in most cases they are digital. On the left side, you can see the example of mechatronic interconnect devices. That means in this case, you have an injection molded substrate that is then structured by a laser. In these areas, you want to have circuits later. And afterwards, you can do a metal plating. In this case, it's done with copper, nickel, and gold. And this process is selective, so only in the areas where the laser have activated the surface before. In the last step, you can do a 3D assembly. And here you have the final product. On the right side, you can see some examples of digital technologies, printing technologies, but also the process chain of system in foil. Here you design your layout on the computer, and then you can transfer it to the printer, in this case an inkjet printer, and bring the layout direct on the surface of your substrate. After this, you can do a sintering and a 3D assembly, so you have also the final product. We use these technologies and process chains to integrate functions for different applications, and this could also be an upgrade for packaging to have a smart packaging, for example. So I want to show you here some examples I think that make sense also in a packaging. For example, a light application that is here on the left side done by the MID process chain, but also capacitive touch sensor that is done with the system in foil process chain on a PI foil in this case. And the other examples are done by printing technologies. For example, a temperature sensor or a humidity sensor to observe the environment, but also intrusion sensor or a heater could be interesting for packaging. The same, for example, an antenna to send the information of the sensors, for example. So as you can see, we work a lot with plastics. So the technologies I have presented come from the thermoplastics. You can see on the left side. Here we use different processes to manufacture the substrate materials, mainly injection molding, but in the last years also additive manufacturing took a great part in our work. And also foils like PEEK or PI foils are quite interesting for our applications. Nevertheless, we have worked the last years to transfer our processes also to thermosets because we can use it for other applications. And you can see in the middle some examples that are made with additive manufacturing. Here we have developed a process chain to functionalize materials from different additive manufacturing processes. And in the electronic packaging, we use, for example, the epoxy mold packaging that is a commercial system in this field. And on the right side, you can see ceramic substrates. We have also developed the process for this material, so we can do applications for power electronics or RF technologies, for example. Because we use a lot of plastic material, we also have some project where we want to develop sustainable materials. Here I want to show you a quite new plastic class, the Vitrimer. So they are between the thermoplastic and the thermoset. That means thermoplastic has the advantage of the recyclability, but the mechanical property and the chemical resistance are quite low. On this point, the thermoset are more better, and the Vitrimers combine these properties. So when you look on the structure on the left side of the thermoplastic, you can see the polymer chains with a quite low network, and they are only structured in small areas. And on the other side, you have a thermoset with a dense network, but this dense network doesn't allow the recyclability. So the Vitrimer combine these properties. They have the polymer chains with a quite dense network, but they also have covalent bonds in the system, and these bonds can be opened, for example, by temperature or also a special solvent, and that allows to recycle these materials. At the moment, we have a project where we work on the process development to use this material in injection molding. So we hope we can do products and applications with this material class in the future. And last, I want to show you a material that can be used also for the packaging. The bacteria cellulose, it's done by a green tea. It's on the top of the green tea, and where we use the cellulose pellicle. And after drying, it's similar to paper. And Treeless Pack, for example, use this material still for packaging. In the wet form, you can also use it as a patch in medical applications, for example. And in 4 days, we will start a new project where we work with this bacteria cellulose to develop a sustainable PCB. On the bottom side, you can see the proof of concept. Here we have functionalized the cellulose with inkjet printing, and this works quite well. So we are hopeful that we have a new sustainable PCB in the next 2 or 3 years. So that was the information from my side. If you have any question, please feel free to contact me. Thank you.
Thank you, Dr. Glaser, for your innovative perspectives and so many details, information on what can be made and produce after once the plastic is already used. Do you have any questions? No, if not, if we will have some, we will be free to direct it to Dr. Glaser and she will answer it later. Our next speaker today would be Mrs. Chiara Calegari from the COMET, the Mechanical Engineering Clustering of Friuli Venezia Giulia from Italy. Mrs. Calegari will introduce how the beer byproducts can be turned into biodegradable plastic. Please, Mrs. Calegari, it's your turn. Thank you.
Hi, thank you so much for the introduction. Hi everyone, my name is Chiara Callegari and I work for COMET, which is the Mechanical Engineering Cluster of Friuli Venezia Giulia, so in Italy. Today I'm here to present Bisograte, a circular economy project where COMET is one of the partners. So Bisograte is a research and innovation project funded by Interreg Italy-Austria. And the goal is to create a new circular business model that turns beer byproducts into biodegradable plastic materials that can be processed using injection molding or even the 3D printing that we all know. The project was developed together with Crossing, which is a spin-off of the Danish University Ca' Foscari, specializing in green chemistry and environmental sustainability. Together, we aim to turn what used to be like waste from the beer production into a new sustainable resource. So before telling you about what we are actually doing, I want to present to you this material we are using, which is called the BSG, or brewer's spent grain. It's the main byproduct of the beer brewing. So it's what's left from the cereal, mainly malted barley, after the sugars are extracted for the production of the beer, to make the beer. It's fibrous, plant-based residue, which is really rich of protein and fiber, and has really great potential for reuse. This spent grain has a very, very interesting composition and a very, really good material. So now I'm going to list what's really of it. It is like 20-30% of proteins and still has a small amount of starch and lipids, as you can see. But it's also very, very wet. It's like 70-80% moisture after it's brewed, and makes it very, very heavy, perishable, and difficult to transport. So we're trying to find the best solution, and it's very important to find the best solution to dry it and reuse it as soon as possible. It's important to know that BSG makes up like 85% of all the byproducts from brewing. So we have like a really large and underused resource. To give you a generic idea of the scale, in 2023, Europe produced nearly 35 billion liters of beer. Italy, about 1.8 billion, ranking 7th in the EU. In general, Central Europe, including like Germany, Austria, and other countries, had made 40% of the total beer production. For every 100 liters, we are creating like 20 kilograms of spent grain. So it's very much, there's like a really, really enormous amount of residue. This makes breweries the perfect starting point to develop new sustainable value chains. Traditionally, brewer's spent grain has been used as animal feed because of its high protein and fiber content. But at the moment, and in the last years, it was banned in the United States. So we are expecting it to also come as a restriction in Europe in not a lot of time. This brewer's spent grain can also be used as bioenergy, like biogas or bioethanol, but this is not very efficient in the moment because the materials, as we said, is very wet and heavy. So processing and transport costs are high, and the return that you can get is really low. Sometimes it even ends in the landfill, so it's just like wasted and it's clearly not sustainable. There are also some new applications being explored, for example, in food or nutraceuticals, like bread or snacks, but we still need to find a really good regulatory approval. So it's like a really long process, and sometimes there is no time for those technical times, you know. So the challenge is that we need to find new, higher value uses for this byproduct, and that's exactly what the project Bisograte is trying to do. The slide shows exactly the circular model developed in the project. So our goal is to upcycle beer byproduct into bioplastics that can be used again to make new items. So how this model works? We start from the top part, which is the brewery, where beer is made from cereals like barley or wheat. During this process, a large amount of spent grain is generated, as we said before. That spent grain becomes our raw material. Then it's processed and mixed with a natural bio-based polymer by our partner Crossing, as we said, creating a bio-based polymer formulation, which we call in the project BSG-BC. These formulations are turned into bioplastic pellets, the small color granules that you can see in the picture, the one that is less green, yellow, and blue. Finally, these pellets are used to make real products, be it trays, coasters, coffee capsules, flower pots, and other items currently under tasting. At the moment, we are focusing on flower pots. So one of our partner is from Vicenza, is creating the flower pots, and it's working very well at the moment. We are very happy about that. At the end, these products return to the market. So we are closing the loop of a circular economy model. So here you can see the process in more detail. We start with a wet spent grain, which first needs to be dried. Then it's prepared and mixed with a natural or biodegradable polymers, so it becomes BSG-BC. Using extrusion compounding technologies, we create homogeneous biocomposite, where the spent grain fibers are well integrated into the polymer matrix. The result is a biocomposite granule. It looks like a normal plastic pellet, but it's bio-based and biodegradable. These pellets can be processed with standard industrial equipment, like injection molding, extrusion, or always like 3D printing, to create new sustainable products. Okay, so this material that we are developing has very, very good properties. It's flexible and semi-crystalline, combining adaptability and it's really, really stable. It's easy to process with standard injection molding, so we don't need to create a new machinery and buy them, so it is not like a really big expense. It has a better heat resistance than many bioplastics. It's plant-based and compostable since it comes from an industrial bioproduct and not agricultural crops. It can be colored for design flexibility and for any need that can be had. And it's cost competitive, while many other biocomposites are much more expensive. So this material is environmentally friendly, technically reliable, and economically viable. And it's really, really interesting at the moment. So in this slide, you can see our results. Here are like the first prototypes that we produced. We've made lids and covers, flower pots, as we said before, coffee capsules, and cylindrical demo parts. We're also testing new items such as bottle holders and aeroponic pots. What's remarkable is that this material behaves just like polypropylene, one of the most common plastic that you obviously know, but it's 100% bio-based and biodegradable. Okay, so to wrap up this project, Biodegradable is a concrete example of a circular economy in action. Instead of treating brewer spent grain as waste, as is usually done, we've shown it can be transformed into valuable biocomposite material. This brings multiple benefits, as you can see. So we have the environmental one, by reducing landfill and fossil plastic use, economic, by creating new green value chains among breweries and manufacturers, and sustainable, by proving that circular manufacturing works in practice. So Biodegradable shows how something as simple as beer byproduct can become eco-friendly. It can create opportunities for the planet and for the economy, and also for something that was never meant to be used as a different kind of different use of some product. So thank you very much for the attention, and if you need to get in touch or to have some question, feel free to contact me here. Thank you.
Thank you, Ms. Calegari. Any questions for Ms. Calegari? Short one. Yeah.
Hi, thank you. Do you know the reason why the BSG has been banned from use as an animal feed?
Yes, because at most times when something is used for the animals, it usually doesn't go under a lot of controls. So it's mostly just like put in some bags and just given to them. So it's not really well controlled. So usually it's what's happening. It's like hidden inside some pellets for the animals, and it's not really good for them. And in Italy, in Europe in general, we have a lot of controls for that. So it's not the most safe food for the animals. So, and then the animals, we eat the animals. So it's just something that inside the human is really good for health in general.
Thank you. Thank you very much. Any more questions? No? Then we can go to our next presenter, coming from Czech Republic. I would like to welcome Mr. Ondrej Venclik. Yeah?
Yeah.
Thank you. So let's hear Mr. Ondrej Venclik is coming from a Plastic Guys company, and he's about to present us how plastic waste can be turned into 100% recycled panels for interior and furniture. Mr.
Perfect.
Venclik, welcome. The floor is yours.
Thank you very much. Hello, and thank you for inviting me for this session to Zadar. Welcome, everybody. You can call me Andrew anytime. I'm an architect, so I will show you a lot of pictures, and I don't like text, so it will be a really cool and quick presentation. So right now what we are dealing with is this problem. This is not in Europe, but it will be maybe sometimes. It's not in Europe, but we also have it in Europe, and this is in Czech Republic, and it's disgusting. I don't like it. So you can see in the behind there is a lot of dirt already been placed over, and we don't like that. So we come with the solution, and we doing the new panels from recycled plastics. We take industrial waste, melt it together, make it into the panels, and use it for furniture and architecture. So as you can see, there is like a lot of textures, a lot of entering material with different colors. We use thermoplastics, and it's really easy to work with. We melt it and make this kind of textures, which is really cool and nice and unique. Every panel is original. You can also see there is like a lot of plastics, which is like PET bottles, which are transparent, and if you melt it and glue it together, you can see the sheets are also transparent. So it's a really cool effect which you can work with, and you can also bend the material again. And what is the most coolest thing is that you can already and also every time recycle it again, because it's only 100% plastic waste. We use polystyrene, which is the thermoplastic group, and from there we can recycle our waste again and again into the another panels and in other sheets. And also, as you can see, we are just not making the panels, we are also go into the furniture market and said, yeah, let's do a finished product. So I hope that you like it. This is like one of our new things we got here, which is also this kind of cool lamp. And if we put it together, we can light it up. And so I can show you and see the effect directly. So yeah, you can see the material is totally transparent, which is cool. And we make this kind of products. So from there, you can use it in every position. It will be coming in flat packs, so you can easily glue it and screw it together and have the final product. So we combined it with another materials like metal, cotton, and pillows, which is cool. So we want to show the material how it's hard, how it's cool, and how we process it. And also we can use it totally in inside usement or outside usement, because company MMCT is one of the biggest furniture company which make like bus stops and outside furniture, and they put our new material into their portfolio. So we are glad that we can make a lot of new things also outside. And yeah, this is one of the projects we been getting some prizes for design. I didn't design it. I think it's like a basic design, but yeah, also it can win some prizes. But I want to show you that you can use the material in almost any position, in every use. Use it for bars, kitchen countertops, bathrooms, because plastics don't adhesive any water, so it's really cool product. And you can make original textures for any client, or we can do any textures repeatedly. What is interesting, a lot of architects and clients ask us if it's safely to work with food, and we did certifications for food safety and it went well. So when the entering material is from yogurt cups and food safety materials, our panels can be food safety also. And that's it. There is like varieties of colors. I will be glad if you will check out our website and Instagram, and you will see how many cool products, hotels, restaurants, and cafes we do together, and maybe you have it already in your town and you don't know it. Thank you very much.
Thank you very much. We like cool and quick presentations, and especially this one, Dalmatian Stolek. I think Dalmatians here will like it as well, being now in Dalmatia. Do we have any questions? No? Maybe later then?
No
then
problem.
I would like to sorry? Then
No
I
problem.
would like
Thank you
to
much.
Thank you once again. Then I would like to continue with our last but not least online presenter in this session, and welcome Ms. Lili Schweitzer from Pomurje Technology Park, Slovenia, who will introduce us the Circular Innovation Hub, B2 Green Hub, actually, as the newest platform supporting small and medium enterprises in achieving their sustainable goals. Please, Ms. Schweitzer, the floor is yours. Can you hear us? Yes.
Thank you so much. Thank you, Renata, and thank you, Božica, for giving me this platform to quickly talk about our project, CI Hub, and then the B2 Green Hub ecosystem that we built around our project, our Interreg projects. I will try to keep it as short as possible because I am sure everyone's super just excited about the lunch break. So let's get started. So quickly, I would like to talk about the Circular Innovation Hub project that we have at Pomurje Technology Park. Good. Okay. So the core of the project is that we are working towards greener and sustainable and more circular Danube region with the CI Hub project. We are trying to improve the life and the process of the SMEs in this region in the topic of green and digital fields. You can see that on the screen we have 13 partners in this project, and the project started last January, and then it's going to end around June of next year. In the project, we are focusing on 3 pillars. You can see it on the left side of the screen. So we have the circular user acceptance model. We are looking forward to have this innovation hub, which is going to be available next week. And then the last pillar is the policy learning center and instruments. Here in the beginning of the project lifetime, we were focusing on interviewing and getting to know the national SMEs in the partner regions, we were able to identify the key challenges and barriers of those regions, which were generally the lack of awareness of digital and green transition, circularity, low skilled labor, and lack of financial resources. And then we were able to identify key enablers as well, which we used as like focus points for the next phase of the project. The next phase, we developed the user acceptance model, which is a tailored framework to help different SMEs towards their digital and green goal. In the user acceptance model, we again set different KPIs in different regions to help selected SMEs to just identify what kind of direct help they would get. And then this was around the springtime of this year. We were able to help with the green and digital readiness of these SMEs. We worked around like 80 SMEs in this phase of the project to get tailored solutions and expert guidance to them in their specific field they would wanted to improve during this lifetime of the project. And then we were able to identify our offerings also in CI Hub, but you will see in a couple of slides that we have a bigger picture, the B2 Green Hub platform, that's the end goal of our project and also most of the projects that we do in Pomorje Technology Park. We were able to identify green transition tools and services and develop these services within the project. And then the ecosystem that I'm going to talk about, ecosystem of different SMEs, also with different experts, both in digital and green fields. And then the final step here was the e-commerce platform, which is B2 Green Hub, that I will show you a bit later. And then where we are currently with the project is that we are doing or piloting activities right now until the end of the year, where we exactly guide those companies that we worked with before in the springtime in the specific field that the user acceptance model was requesting for them. It could be digital, it could be green solutions. And then we are doing the piloting with them until the end of the year, as I said, where we are coming up with different targeted just solutions for them, guidance for them. And then the final year of the project, so from January till June, we are going to be focusing on implementing all of these solutions and guidance to transnational strategy. And then from the transnational strategy, we will create regional action plans that we are going to implement it on governmental level as well, in some cases. And then everything else that we are doing now is going towards B2 Green Hub platform that I'm going to talk about in the next slide. The big picture I put here. We have B2 Green Hub. This is a really, really complex ecosystem that we've been building for almost a year and a half now. And next Monday, it's going to be available. I got the final answer from our developers right now. And it's going to be available for everyone in the world. I like to introduce this platform as like a one-stop shop for SMEs, for different companies with different backgrounds. I'd like to think about this as a LinkedIn platform for SMEs and for experts. We have 3 different pillars in the B2 Green Hub ecosystem and platform. We are focusing on sustainability, digital field, and the human field as well. You will see that right now we are working with, on one hand, we are working with SMEs that are looking for different solutions, and then we are working with business experts, green experts, digital experts. Then they can help with the SMEs with their problems and their need of development. Right now, we have in the ecosystem around 100 EU institutions, testing facilities, more than right now on this side, I have 150 plus business experts. Right now, we have way more. And then these numbers, of course, are going to increase because this platform, of course, is not going to end with the project, but our institution, Pomorje Technology Park, is going to continue having this platform. This platform was built with or by 7 European Union projects. I'm talking about right now CI Hub, but these are all of the projects that helped to create this platform. Everyone had a different role in building this ecosystem. Here on this slide, you can see on the market focus of green field and digital field. In the manufacturing industry, we were focusing on, you can see on the screen, different sectors, different topics. And then when you go to the platform, what is it for you? As in, you can just look up the platform as an SME who is looking forward something really specific, something that you want to develop, or either you can be a solution provider, an expert who provides those services for the SME. So it really is like a LinkedIn platform, but for sustainability, for green and digital transition. Here you can see if you are a company who wants to develop something, who wants to just get forward in their processes, you can join the community. And after, based on your location and your country, you will be assigned to a key account manager who will do like a first assessment with you, just to see where you are with your company in your specific field, in the digital field or green field, and what can we offer for you. And then when we have these personalized guidance and support for you, we can connect you with different experts, different funding opportunities, demo centers, different EU projects. And then in the platform, which I really like, is that we are going to offer e-knowledge. It's going to be an e-knowledge based platform as well. So we are introducing e-learning modules in, of course, I'm repeating myself, in digital and green fields, which is I think really exciting, because as I stated in my presentation before, when we did the user acceptance analysis in each partner country, we identified that most SMEs really don't know the basics of circularity, and then those basic knowledge, what's missing right now. And then with the e-learning platform, the e-learning modules, we are directly targeted these questions. We are going to release modules that are supporting these knowledge together. And then each SME who completes a module, they will get like a really nice certificate that they can put out in the office, for example, and on their website as well. So it's really nice that we are not only a networking platform, as well as like a one-stop shop platform, but we are also doing e-learning modules as well. And much more, by the way. It's a really, really extensive platform. Next week, I would really urge you to check it out, because we've been working on this for, as I said, a year and a half. It's a really complex one. You can really search into different, really, really specific topics that you are interested in these sectors. I think it's really nice to just get connected with different like-minded people in the European Union, and then find examples that can lead you to have a better process in your company. And if you are a solution provider, an expert, you can advertise your services as well on the platform, so that it's a matchmaking as well. And also what I really like is that on the platform, we are going to have a forum as well, where anybody who registers on the platform can ask questions, and then solution providers, experts can give really detailed answers and then valid answers. So it's not like you're searching the answers on Google and sometimes it's false information. On the forum side of this platform, you will get valid information in your question and in your specific topic, which I think is really nice. And here you'll see how to join. You can scan this QR code, or you will see my email at the end in the next slide. You can also contact me, or go to PTP, my company's platform, but of course feel free to just write me an email if you're interested. And then just next week you will be able to search in Google b2greenhub.eu. If you're interested. So that was in a nutshell. I know I haven't touched on really specific topics, but I just wanted to give you a big picture of what we've been working on. So thank you so much. That was all.
Thank you, Ms. Schweitzer, for sharing this initiative, this access to platform that will be hopefully available next week internationally, right? And we're looking forward also to join and connect our companies with this platform, of course, and to make them use this one-stop shop easy way. I hope they will know how to use it. Do we have any questions maybe we have?
I would like only to comment. Congratulations, Lily. And we already feel a part of B2 Green Hub, because our project manager of Greenie, Ula Woźniak, who is watching us, is responsible for joining forces between B2 Green Hub and Smart Circuit. So as the consortium, definitely we are very much interested, but as individual partners also, yes. So we deep dive into the platform next week. And what I would like also to mention that just by joining the forces and looking for synergies, and referring to Martina de Sol presentation, there is a special task force dedicated to circular economy that we are also a part of, and we provide some perspectives and insights. So thank you very much, Lily.
Thank you so much.
Thank you, Agnieszka, for your contribution. If there are no more questions, with these lines from Agnieszka and from Lily, I would like to conclude this session on innovative projects in circular plastic and advanced materials. Once again, I would like to thank to all of the speakers for their inspiring contribution. And now I invite you all to take a not so short lunch break. Welcome back. Participants here in Zadar and participants attendees online. I hope we can continue with our second part of the day with our masterclasses, focusing on key technical and strategic topics. Our first masterclass speaker is here with us, Mr. Arno Dalmatinac from the University of Zagreb, Geotechnical Faculty Varaždin. He will share with us his in-depth insights with practical perspective on extended producers' responsibility. So, Mr. Dalmatinac, let's see what additional responsibilities producers still have to bear. The floor is yours.
Hello, everyone. Do you hear me? Yes. Okay. Okay. My name is Arno. I'm from University of Zagreb, from geotechnical faculty. And today I will speak about the extended producer responsibility. So in today's world, we speak about sustainability, about waste management all the time. And it is time to define what that actually means and what are the details regarding that. Okay, so we'll start off with waste management in general. People think of waste as something smelly, something ugly, and something we don't really want, and that is partially correct. But there is also the whole science behind waste, and we're going to cover a part of it here. We usually do that at my faculty, at the Faculty of Geotechnical Engineering. We have an environmental engineering study program where we teach students how that is done. Okay, so let's start with the definition of waste. Waste is everything that we once used, all the products that we no longer need and then need to discard. For example, this pointer, my phone, will at one point become waste. The problem or the thing is how we will manage that waste. Will we throw it into the environment where it will cause harm, or will we act with it responsibly? Why do we even do, and what is waste management? So waste management is a group of actions we do with waste in order to prevent pollution, in order to act accordingly. First reason, there are three reasons why we do it. First one is human health. So if we allow waste to build up, we are risking human health. There can become, diseases, we have disease outbreaks and similar. Second reason is pollution, and this regards to the environment in general, animals, plants, and such. And it is directly connected to the first one, because if we don't have a healthy environment, we cannot be healthy in it. And third one is natural resources. So there are many natural resources in waste that can be recovered and used once again. If we just discard things, we can never use them again. Okay, this brings us to the point of our economy, how it is set up. In the past, we had linear economy. So we would pull some resources from the earth, we would produce a product, and once upon we finish using that product, we discard it into the environment, and that's it. After that, we pull new resources, make a new product, and then discard them again. Here comes the circular economy. The difference is we pull these resources, we apply some sustainable design to our product, we produce that product, distribute it, and use it. And after its life cycle has ended, we collect it for waste. We collect it and we put it into the waste management system to deal with it accordingly. Now, waste management system, there is one thing about it. Not everything can be used. 1% will always be waste, and that part will need to be, once again, dealt with accordingly, but the other part will be able to be reused again, and the cycle continues. On the right side here, we have the waste management hierarchy, and people often ask me why is the pyramid upside down? Because the upper parts are have a higher priority. So the first thing, we need to prevent waste from even happening. Okay, if I use single-use bottles for my drinking, okay, I can get one bottle, drink, and throw it away, and do the same tomorrow. And in a year, theoretically, I will have used 365 bottles. But if I use one bottle that I can repurpose multiple times, then I have only one bottle per year. And that way, I'm preventing waste from even coming to life in a way. And second one is reusing. Okay, we can reuse many products once again after their initial idea of usage has ended. Third one is recycling, and it actually is a group of mechanical processing and and well, let's say processing, where that product will be turned into something new and something different. The last one, or not the last one, the pre-last one is recovery. Once, if we cannot recycle a product, we put it to recovery. For example, we burn it and use that for energy generation. And the last one is disposal on a landfill when there is nothing else we can do with that product. Now, the basis of this whole masterclass, the idea is the polluter pays principle. So those responsible for environmental damage should pay to cover the costs caused by their activities. What does that even mean? I have here a few pictures. So this one, okay. The first one down there, we have some construction waste left by the dumpster. Let's say, hypothetically, I left that there. Who is responsible for that? I am. Who will pay the bill for that? I will. Now, on the down picture, we have some furniture also left in the nature. Who is responsible for that? I am. On the other two pictures, we have two items that are very common. A mobile phone, everybody uses one of them these days. And on the right side, we have a fridge. What is different with them? These are mass produced. So many of them are out there. And there is a certain risk, environmental risk, if they end up in the environment. Okay, how will we control that? The idea is that the producer of these products will pay an additional fee for these products to be disposed of accordingly later. That's the idea, because there are so many of them and they have a possibility to make to cause big damage in the environment. We'll come to more info about that later. So here is the essential, the basis. So extended producer responsibility is a policy approach that focuses on the producers and holds them accountable for their products along the entire life cycle. These categories are included in the extended producer responsibility. So all the packaging, like bottles and plastic bags, waste electronic and electric equipment, end-of-life vehicles, tires, batteries, oils, single-use products, single-use plastics, and soon textiles will also be included. Now, here are the four main pillars of EPR, what it's actually based on. The first one is the duty of preventing pollution, which we talked earlier about why we do that. The second one is life cycle concept. So every product has its life cycle, from its production to using to the last part where it's discarded and it goes into the waste management system. So that's one part. The third one is the polluter pays principle, which I talked about previously. And the last one is the internalization of costs, which is not maybe the best term for this one, but here we have it. What that actually means is that the waste management system has many elements, and all these elements cost money, and all these things need to be built. Someone needs to pay for those things, and who is that going to be? That's going to be the producer. So the idea is that all the costs related to that product will be internalized in the final price of that product. Now here is a little scheme that will probably make it a little bit simpler. So we have the producer who makes a product. The product goes to the consumer. Consumer uses it for a certain period of time and then discards it. It becomes waste. After it becomes waste, it goes into the waste management system. And that waste management system has its elements that all aren't free, actually. They cost a lot, from collection to transport to sorting of that waste, recycling and final disposal. Not to mention the more administrative parts like information and education of the people, data collection, reporting to the European Union, and administration. And also there is 1% that goes to the country budget. So all these things cost money. So who pays the bill? That's the problem people often ask me. Okay, who is going to pay for that? So producer makes a product, and that product has its price. And that is this first dollar sign. Okay, that goes to the product price. Next, we have the cost of collection, transport, sorting, recycling, and final disposal. That also costs money. Okay, what's going to be with that cost? Who is going to pay it? That is also shifted to the producer. Now, the green dollar is for recycling because not every single material is going to be a burden. Some materials have a cost. For example, aluminum is very valuable. And for selling aluminum, you get money. But for some plastics, it's different. You don't get money for plastics, but you need to give plastics to the company who is going to take your plastic, because it does not have that big of a value. So that's why this one is green. It can be positive and negative. Okay, that one also shifts to the producer. And also we have the cost of information, education, data collection, reporting, and administration. That also costs money, and that is also shifted to the producer. Okay, now the producer has additional costs, and what will happen with them? They will all be shifted to the product price, one by one. And now, what happens with that? You can all guess. Who is going to pay that? That's going to be the consumer. So the price of the product won't be, for example, 10 euros. It will be 15 euros because of these additional costs. Okay, now let's go through the waste management law in Croatia and what it has to say about extended producer responsibility. So producers are required to oblige to certain things. They have to ensure the products meet prescribed technical and safety standards, keep accurate records of those products put on the market, properly label products, submit required data, etc. Those are more or less standard things. Then we have additional. Okay, they have to take back used products and ensure collection of waste resulting from their use. Okay, if I put a fridge on the market, I have to be accountable for its disposal later on. They also have to pay the waste management fee, and that goes with that's defined by the waste category. They have to inform the public about reuse and recycling options, so that you know, okay, I have an old fridge, I can take that either to the recycling center or someone can come and pick it up. And also they have to register in the Registry of Producers with Extended Producer Responsibility, the RPPO, into that register. Now, these obligations all apply equally to all producers, no matter how big or small they are. It can be a two-person company or 2,000-person company. Also, if it's a foreign company, they have to appoint a certain company in Croatia who will do the EPR for them. So they are not bypassed in this situation. Okay, so I said that these obligations apply equally to all producers, regardless of company size. Okay, which producers are actually obliged for this system? So those who use certain products, those who produce them, and those who import and export them. So that the UP and EE. Now, for the waste categories, I had them listed before. Here we have it again. So all those who use packaging, produce and import and export are obliged to be in this register. For the other categories, waste, electronic equipment, for vehicles, for tires, batteries, only if they produce and import and export them. So, okay, you use a car, you are not obliged to use that register. That's logical. Same goes to fishing tools containing plastics. Okay, you use a fishing rod, you are not required by law to submit info into that database. You are just, the person who is selling that is required to. Okay, now we go to labeling and information. Generally for single-use plastic products, there are certain mandatory labels that need to be visible, legible, indelible, so that you cannot remove them, and they have to be indicating that there is plastic in your product. For example, you buy some wet toilet tissue or cigarettes or something containing plastic, and it will have these labels on them. Yeah, that's pretty much about that here. Okay, so we talked about the Register of Producers, and that's the RPPO, Electronic Database of Producers, and it is maintained by the Environmental Protection and Energy Efficiency Fund. We'll talk about that in the next slide a bit more. It's one of the crowning organizations about waste management issues in Croatia, and also in cooperation with FINA. So it contains data on compliance with EPR, obligations, and contributions. So how much waste did you put to market? How much is it going to cost you? What are the fees? And all that things. This data is publicly available, with the exception of some trade secrets. In those cases, it will not be publicly available. Okay, this is how it looks. This is just one page where we have certain reports. And okay, that's going to cost you, I don't know, 400 euros. This one is going to cost us 3,000 euros, and etc. But it's all together a very integrated system. Okay, now I've talked about the fund, and the fund, Environmental Protection and Energy Efficiency Fund, is the main institution in Croatia, and it is under the direct control of Ministry of Economy and Sustainable Development. So the roles of this fund is the financing and managing of projects in the area of environmental protection and waste management. So, and also energy efficiency. One more thing that is important about the fund is that it's the main body that focuses on implementing EU and national environmental policies. So we have certain targets for recycling this type of waste, waste, and the fund is going to be responsible for keeping track of that. Okay, here is one small chart. Okay, fund is currently not the only organization, we have two, but fund is the main one. The law also allows for other organizations to be formed. For example, we have a few producers, let's say 10 producers, who don't want to be in the system of the fund, but want to create their own system, their own organization. They can, and that organization is then obliged to reach the set waste management targets. Of course, the ministry allows this or doesn't allow this. If the establishing of that organization will be positive for the waste management system of Croatia, it will be allowed. Currently, such a system where the fund is the crowning organization is only available in Croatia and in Hungary. And in Croatia, the other organization we have is for hazardous packaging. For example, packaging containing certain oils or flammable materials and such. Okay, if that organization came to be, it needs to ensure nationwide accessibility of waste selection. For example, we have one small island and we have some hazardous waste generated on that island. Okay, the service of collecting and transporting and dealing with that must be available to those on that island. Otherwise, that waste would probably end up somewhere on that island and cause pollution. And that's not among the goals of the ministry and the country in general. And the ministry supervises their activities. Okay, now let's go back to the EPR and the financing and costs. So the producers bear the cost of, first off, separate collection, transport, and treatment of waste. Then we have public awareness campaigns. This is what I told you about earlier. You need to educate people on what can and cannot be done and how the system works. And the third thing is the return systems and incentives for waste handover. For example, we have the okay, I'll talk about that in the next slide. But the returnable packaging, like bottles that you return to the shop, that is also part of the system of the fund. Okay, the summary. So that chapter X from the Croatian waste management law establishes a legal framework that shifts responsibility for waste management from consumers and public authorities to producers. And this approach encourages higher recycling rates in a way because some of these products would ultimately end in the environment, and reduction of landfill waste because some of these products will be processed in a certain factory in a better way than they would be if there would be no funding available to do it. So we can say that altogether it contributes to a more circular economy. Now, what about the material and financial flow? I will explain this part on an example of packaging. So we have some waste that we collect. For example, on the down picture, we have a waste truck. Okay, so we collected our waste and the trucks comes and collect it. Okay, what then? Okay, we also have an example of a bottle being redeemed at the stop. Okay, what then? What's with the money and what's with the material? Where does it all go? Okay, so here we have a little graph. Okay. Okay, yeah. So the thing here is we have the fund as our crown organization, and we have the producer. So producer puts certain material to the market. Okay, and that material goes to the consumer. Now, the consumer uses that, and later after the end of life, he has to discard of it. There are three ways which this waste can go. First one is separate collection. And this is part of this here. So we have waste packaging from household. That's one bigger category. And then there are two subcategories, separate collection. That would be those separate collection bins, for example, yellow one for plastics, blue one for paper. And then we have the deposit system where we take our bottles to the shop. Okay. And there is the third one, which concerns the companies. For example, that shop, they have cardboard boxes or bigger foils or bags. And that is waste packaging as well. Okay, now we'll focus on the first one. So after we separately collect our waste at our home, for example, some bottles, some cardboard, some newspapers, etc., and we put them to the bins, the truck will come and pick it up. Okay, that is under the waste management company, the local waste management company. Okay, we here have the blue arrow pointing. Okay, the fund will have to give some money to that company for the packaging. So here's the difference. We have packaging that is a part of the system of the fund, and that is not the part of the system of the fund. And for that packaging, for example, bottles as such that are defined, the fund will give the company certain amount of money to cover the costs. That's the idea. Okay, now we have that waste, and that waste will go to a fund recycler. This is the big box down there. Other packaging that is not in the system of the fund will go to the classic recycler that is not in the system of the fund, and the recycler will not get any money from the fund to cover the expenses. That is entirely on that recycler. Okay, the next one is the deposit system. Okay, so the producer sold us some water bottles. We used them and we discarded them. We brought them to the shop and left them in the shop into the machine. And we got some money back for that. Okay, now what happens with that? Okay, first off, that shop has some expenses regulating that. The shop has to get that machine that will sort those bottles. Okay, that costs money. So the fund will give some money to the shop in order to establish that system. Second off, after those bottles are collected from the shop, they are transported to the fund collector. So the fund appoints the official collector. Okay, that collector will also receive money from the fund for managing those bottles. Okay, now that fund collector will forward these bottles to the fund recycler. And here we get to one more point. Okay, fund recycler will recycle these bottles into something else, and it will receive some money from the fund for doing that. Also, one more thing that will happen is that the fund recycler, when they sell those bottles, if they make a profit out of them, that profit goes to the fund. If they cannot sell that, if it costs more money than they are worth, it will receive money from the fund. And how did the money get into the fund from the first place? The producer paid that money into the fund. So that's how that part works. And the last one is the waste packaging from the company. For example, we have a big market and they have those cardboard boxes and big bags and etc. Okay, those are also collected from those centers and are sent to the fund recycler. Okay, and the fund recycler will also receive money to be able to handle the recycling of that waste. So this would be the last one. And we have number 7, income of selling the package. And that income is going from the fund recycler back to the fund. And the fund is going to send money to the fund recycler to cover the expenses of their operational expenses. The last one, the number 10, is the income due to selling the packaging or expense for treatment. So if that packaging has high value, they will be able to get some money out of that, and that money will go into the fund. But if it doesn't have big of a value, then it will cost money to recycle, to dispose of it, and the fund will have to secure the money for the recycler. And that's why the purple arrow goes both ways, from the fund and to the fund recycler. Okay, here are some steps and conditions these materials take in the waste management system. So this is also in the packaging part. So what are the difference? The fund system has pretty much all the other elements, but the deposit system also has the center for packaging and shops. And those are the additional links, in this chain. And same way, the separately collected waste, they have additional sorting, because separately collected waste is often full with contamination. If you, for example, open a yellow big bin with plastics, you will see inside there are, first off, plastics that cannot be recycled. You will see a bit of paper, probably some food, some bio waste, some other things that should not be in there. So you have to sort the waste in order to process it. Okay, here is a bit of statistics. Waste electrical and electronic equipment in Croatia. This is from the last report from 2022. So the collection goal was 65 in 2019, and here we have the trend. How much did we achieve? To what extent did we achieve that? So at one point we did achieve it, and then we had a downward spiral. Why is that? It's one of the reasons is because we have better data reporting now, and some things that were in the dark before or over-reported aren't anymore. So that's one reason. And the other reason is that there are some things in the waste electric and electronic system that need to be fixed, improved in order to reach the level where we were before. Here are the exact values for recycling and recovery. And these are also the percentages. And this is one area actually where we are very good. So for example, the recovery rate for heat exchange equipment, for bulbs, for pretty much every category of these, we've reached those goals and went even above it. So the recycling rate is 96% and the target was 80%. So in this area, Croatia has reached its goals. Okay, here is the collection about. Okay, so recycling and recovery, those are two things where we make a new product, and collection is just the collection. People often mistake those two. For example, they say, okay, we recycle at home. No, you don't. You're just separately collecting things. Recycling is a whole different stage that happens afterwards. So these two things need to be understood. Okay, so the collection, here we also have reached those goals. Now for batteries and accumulators, for the recycling, here is the situation as well. The target was 65, 75, and 50. And we have reached the target in the lead waste batteries and accumulators. We have exceeded it. In the nickel cadmium waste batteries, we haven't. We are almost there, but not yet there. And in the category of other waste batteries and accumulator, we have also achieved it. Here is the global packaging put on the market. What is put on the market in 2022? And this is the Croatia. So we actually have a pretty low amount of packaging put on the market compared to, for example, other European countries. Here, the orange bar is actually the mean, European mean, and we are far, far below it. Okay, here is the recovery. So the recovery rate was set at 60%, and we are not quite there. Also, the reason why we have a reason of a decline is some things in the system were differently inputted back at the beginning. Here is the recycling rate, which is almost there, not quite there, but almost there. Now, okay, as we talked about the EPR, we have one more thing to address, and that is the universal fee. So we said that the producer have to pay a certain fee to the fund in order to cover the waste management expenses. But is that fee universal for all the products and all producers? So it's actually not. We come to eco-modulation, which is an idea that the EPR fees should be adjusted based on the environmental impact of a product put on the market. So, for example, we have a glass bottle that is made entirely of glass, and we have entirely of virgin glass, and we have a glass bottle that is made from recycled material. okay, we should encourage recycling and use of recycled materials, and thus the fee for the recycled bottle should be less. That's the general idea. So if the producer introduces better design and better recyclability for their items, there should be a lesser fee. And if they introduce hard to recycle materials, there should be a higher fee. And now here we come to a few criteria for that. So recyclability is the first one. Is that material easy to recycle or is it not? If it is, the fee should be smaller. If there is a bigger amount of recycled content in that product, it should also have a smaller fee. If it can be reused or refilled, once again, without crushing it, without disposing of it, firstly, it should also have a smaller fee. The same way goes with material composition. Is it single material or is it multi-layer? Do we have, for example, plastic, paper, and aluminum in that product, in that packaging, or we have only plastic? Okay, that only plastic product will be much easier to recycle than the first one. Also, some substances with bigger footprint that are potentially hazardous need to be taken into account, like if it has some dangerous inks, additives, or hazardous materials inside. And lastly, weight reduction. Okay, can the packaging of a certain product be more lightweight without losing functionality? Okay, can we use the plastic bottle with it having less plastic in it, or can we not? If we can, why not use less plastic? Okay, per one bottle, that will not be much of a difference, but per million bottles, that will be a big difference. And here is an example of how it would work in practice. So accumulation has been implemented in Croatia very recently. And this table is actually not the exact figures how it is set up currently. This is just an example for you to see, for you to understand how it could work. For example, we have a glass bottle with no cap or no label. And base fee for that bottle for, I don't know, 1 ton of these bottles would be 30 euros. Okay. Now, number of materials used for that bottle is 1. Okay. And if we have only 1 material, which is the bare minimum, we have a certain factor. So it's the red column, number of materials used factor. Okay. That factor is going to be 0. So it's not going to affect it in any way. Okay, and the blue part is, okay, number of recycled materials. For every recycled materials, the price will increase for 30%. That's the theoretical idea. It's not exactly set up like that. It can be 30%, 40%. This is just for you to understand how it works. And at the end, we have the eco-modulated fee, which is going to be 39 euros. Now, okay, let's take that glass bottle and add a steel cap to it. Okay, now we have 2 materials, which is going to be automatically harder to recycle. We just don't put it into one machine and be done with it. Okay, we have to separate that cap and separate that cap from the bottle. Okay, that's going to add additional 0.2 factor to the number of materials, and it's going to add additional 0.3 for the recycled material factor, because we currently don't have any recycled material in it. So the initial price is going to be 30, and the next price after that is going to be 45. Okay, remember 45. Now we have that same glass bottle and with steel cap, but that steel cap is recycled. Now the eco-modulated fee is not going to be 45, it's going to be less. It's going to be 36. It's still more than the classic bottle, but it's less than the classic bottle without the recycled cap. And now the logic continues on. For example, at the end, we have a PET bottle with HDPE cap. Okay, the starting base fee is 10. And taking into account that we have 2 materials inside and that none are recycled, the eco-modulated fee would be 17. Okay, now let's add a PVC label. We have one additional material that's going to be extra 2 euros. Okay, now let's put the same 19 euro price and let's change the PET bottle into the recycled PET. Okay, that's going to be now 16 compared to 19. Okay, let's add a recycled cap. Okay, that's going to reduce the price even more from 16 to 13. So that's the idea of how to encourage the producers to use the more eco-friendly packaging and the packaging that can be that is easier to recycle, because there is no other way they will do it unless there is a certain fee for it. That's how most of the things in the environment work. Unless you build something, things are not going to change, because the financial part about the production of things is the main one. How much profit can I get? Okay, if I can squeeze as much profit from it as I can, I will do it that way. Unless, no matter what the environment say, unless we have certain laws and principles applied that will shift that focus towards the more responsible packaging and products. And in conclusion, so I've talked about the polluter pays principle, and the extended producer responsibility is actually based on the polluter pays principle. And eco-modulation is actually just an extension of the EPR. It's actually a way to make EPR more fair towards those producers that produce more eco-friendly and are environmentally better packaging, let's say. The idea behind these instruments is actually to achieve targets and objectives set by the European Union regarding the waste management and environmental protection. Also, it is to promote sustainability, because sustainability is key today with as much waste and as much environmental pollution we currently have. And we need to reduce the impact of our activities generally on the planet. And this is one way of doing it. Thank you very much. This would be it from me. If you have any questions, please feel free to ask.
Any questions? Any questions? I believe it's the producers who should ask questions here, huh?
I will ask later.
Later then. Okay, if there are no questions, I would like to thank Mr. Dalmatinac for his contribution today with his masterclass, which was very informative even for us, let's say, end consumers, to see how it works to manage waste in a proper way. Next, I would like to invite Mrs. Susanne Kroll from Fraunhofer, Germany, who is going to present circular strategy for single-use packaging. Please, Mrs. Kroll, the floor is yours.
Yes, thank you very much for the kind introduction and the possibility to be here in Zadar. So it's a very nice place, and I'm very happy to be here. And today, like you mentioned, I will talk about the circular strategy for single-use packaging. And I extended the title a little bit, but there will also be a little view on some single-use products. So I think it might be interesting to have that here. Thank you very much. So at first, I will give you a short introduction into Fraunhofer, where we come from. Afterwards, I will talk about the disabled packaging of the households. We will see some comparisons to Croatia. So it's very good to compare that with Germany and how it's currently work in Germany. Afterwards, we will have a closer look on a special branch. So this is the healthcare industry, because there are also a lot of waste which might be interesting for different industry to increase the resource efficiency there. And there will be afterwards a small summary. The Fraunhofer IWU is one of the largest Fraunhofer institutes. So our headquarter is based in Chemnitz, but we have also different stations, for example, in Dresden, where I am sitting, and we have also in Wolfsburg, where we directly work together with Volkswagen, and we have some places in Leipzig and in Zittau. And the Fraunhofer IWU was founded in 1991. We have around about 685 employees and an overall turnover from more than 60 million per year. And myself, I'm directly within one of these scientific files. It's the function integration and system integration. So yeah. And I'm here in one of the departments considering sustainable fiber plastic compounds. And I'm the group leader of the high performance composites and circular economy. And also one of the coordinator from the cluster Circular Saxony. So where we have a close look on all kind of different circularity solutions in different branches. In my group especially, I have the focus on plastics and composites. So composites, and we're talking about fiber reinforced composites with glass fiber or with carbon fiber, but also with some natural fiber. And when we look here, we look at end-of-life parts as well as the design for composite, considering products in maybe products for the automobile industry, for aircraft applications, and so on. And in circularity, we have mostly the point, we have a part which is end of life, and afterwards we have to decide, can we use this a second time? Or it's possible to reuse? Do we have to repair, or can we recycle? Or is there a possibility to repurpose? Does that mean to use that for another solution, for have another function? That's why we're also considering, for example, here, so it's not that easy to use that. So to have inspection. So we have afterwards to decide it's how many defects are inside of a part, and do we have to repair, or can we have this part with this defect for maybe a second uses phase. I mentioned that, so we also have these different waste separation possibilities in Germany, comparable sometimes maybe to Croatia. There's also these extended producer responsibility, and what we can see here, we have different bins to collect the different materials. We have, for example, a blue bin where we collect newspapers, boxes, and books. We have the yellow bin for the lightweight packaging, and lightweight packaging in Germany means that we also consider here products out of metal, products out of plastic, but also composites, which means the same, maybe like here, these Tetra packs or something like that. We have green and brown bins for the glass collection, brown bins for food scrap and garden waste, and the black bins considering all these things which are not recyclable. And we have special collection points for battery, electronics, and hazardous waste. So when we have a deeper look to the packaging waste in Germany, there is this yellow box, and we have this dual system with the extended producer responsibility. So the manufacturers and distributors have to pay a fee to the dual system, and they must be listed or registered on the Zentrale Stelle für Verpackungsregister, so that afterwards the fee can be used for the collection, for the sorting, and for the recycling. And in general, the dual system, have special companies, recyclers, local recyclers who do afterwards the recycling of the system. And when we look at some special numbers which we have here, so with the yellow system, we can collect around about 2.5 million tons of materials in a year, but not all of that is plastic. So around about 1.2 million tons a year of that is plastic. And within the last years, there was a big increase of the recycling rate for the plastic. Currently, we have nearly 70% of the plastic which is recycled, and that is round about 2/3 of that what is collected. If we look here at some special data, so we have to those local waste contractors who are fully paid by the dual system. They do the sorting and in general also the automated, by automated systems. It's mostly near infrared scanner, magnets or eddy current separators, using air jets to separate. That afterwards there can be at first the separation if we have metal, composites or plastic or residual waste. And I've already mentioned that around about 60% of the material is afterwards available for recycling. Around 30% can only go to incineration, and 10% are contaminated that they cannot be used afterwards. Here is a little bit in more detail which kind of materials are going to recycling. So it's maybe comparable to Croatia. The PET bottles are some of the very interesting things. Maybe all of you know that there are a lot of them going nowadays also into the textile industry, not only into producing new bottles. We have polypropylene, which is used again for packaging, pipes and household goods. We have polystyrol for isolation material, for example, low density PE films for garbage bags and construction foils. And most of the time we hear in television or others that there is a lot of export of this plastic scrap, but now we reached around about 7 to 10%, which is still exported for recycling in any other countries. And if we look at special numbers, where does these packaging scrap going to? So most of them, so 30% is going to packaging industry, around about 24% go into construction sector. Some of them is going to automotive industry or other consumers, like the clothing industry and other households. And if we see, for example, here the construction industry on the right side, it's one of the biggest industry which take all the plastic products or a lot of the plastic products from the recycling. I think what is maybe a little bit different to Croatia is that in Germany, we do not really have an increase of the packaging amount. We have an increase, so it's not a decrease, it's an increase. And if we look at that number, that's round about an increase by 4%. So if we look to compare what will be in 2029, we will still have more packaging. So that's definitely need also within Smart Circuit to find more solutions. What will we do with all this scrap? And you already mentioned today a lot of different solutions, what can be done with the plastic, with the waste plastic. Here I will show you a special thing. So it's a company, it's called Polymer Park and Graph. So they developed a very interesting technology because they developed an integral foam. So inside of the foam, you have a very low density. Out of the foam, or on the outer skin, you have a higher density. And that's why these flooring, universal flooring, is very stiff. And here we have 100%. So it's not that typical that we have 100% plastic from the yellow bag. And they, for example, use that for, like you can see here, in the automobile industry, for boats, but also in the construction sector. and it's fully recyclable. And if it can be compared with aluminium or with plywood, there is definitely a high reduction in the CO2 footprint. So it's a quite interesting application. When we have now a special view at another branch, so going from the households to the healthcare industry, Fraunhofer is also going here in some special projects. Because of that, the healthcare industry is the 5th largest waste producer in Germany. And around about 1.4 tons of waste are generated each year per bed, which you have in a hospital, for example. So it's a very large number. And for example, between 7 and 16 kilo of waste are generated at every operation which takes place. So considering all the number of the hospitals we have, it's a big waste problem currently also in Germany to go on with that. And in Germany, around about 5.2% of all global green gas emissions are made from healthcare industry. And if we look also at that special area, it's not only packaging, it's a lot of waste they generate, but here it's also a big topic that we have these one-use products. So we all know if we go for industry, to avoid any contamination, to avoid any infections, you change the material very fast, and that's why you use there also often plastic products. And due to the fact it causes a lot of efforts and a lot of costs to do decontamination, or to use, for example, metal tools, it's usable to have single-use products of plastic. What we did currently, or what we did in the past and what we do currently, we have some projects regarding how can we do the waste management in the healthcare industry. And if we have a closer look at the materials which we have here concerning plastics, there's standard utility plastics, it's around 70%. So we consider here all polyethylene, polyvinyl chloride, polypropylene, something like that. This is used for, you see some examples on the right side for this special single-use products. We have 20% of engineering plastics which are used there, for example, polyamide, polyester, which are used for surgical instruments, for shells, for skirts, for adapters or catheters. And we have only 10% high temperature plastics like polyamide, polysulfones, something like that, which is used for chirurgical instruments, tablets, or implantate who are inside of the body. And what we have seen here, that when we did a survey, or partners did a survey at over 263 hospitals, they analyzed that 90% of the medical waste is not non-infectious, so it's only contaminated, so it's dirty, and it's belonged to the classification category 180004. So there will be, or can be, the possibility to increase the resource efficiency here. And after having a deeper view for the hospital in Dresden, for example, and also a hospital in Halle, we saw that round about 500 grams of plastics per patient per day is a high amount. And that's why we are looking for special solutions for that waste. And here it's definitely the design for circularity is one topic, but also there's a topic to involve all the stakeholders and also the the hospital itself and the nurses, and how to develop with them a special solution for collection of all these waste. Because due to their limitation in time, they're always in a hurry, they are not best paid, and on the other hand, they have no place in the hospitals, so they have to find a special solution for the collection itself. In most of the hospitals, they have color system containers, and on the containers, they have also an information what should be put into the containers. And the nurses and all the doctors are trained regularly on the topic, how to collect the waste. But in general, it's not that easy because they have another focus. Their focus is to help the patient. It's not the focus to collect the waste. So that's another job they get. So we have definitely to find a solution how it works. And behind that, we have all these waste law. Today, we've seen a lot of that. We have not only the European standards, which we have to follow, we have also the German law, the circular economy law, but we have more. So I think the German are the ones who like to generate any new standards and to make maybe a little bit more. And on the other point, like you know, we have not only Germany as one group, we have also 16 federal states in Germany. For example, we are based in Saxony, so it's one of the states. We have Bavaria, we have Lower Saxony, we have Berlin, we have Hamburg, so we have 16 of that. And within all of these federal states, we not have the same standards. So sometimes there are small deviations between one standard and the other, but which is, for example, allowed in Bavaria must not be allowed in Saxony. So it's making the topic more complex. And especially if we look at the healthcare industry, and that's why we also have all the time to integrate the political people, because if we think about a new solution for the healthcare industry and they don't agree to that and they say, okay, it's not confirmed to the law and I'm not interested to find any new solution, it's a stopper. And that's why we here work clearly or strongly together with them. And it's always a aim conflict within a healthcare industry. On one side, that must be safety. You have to avoid any risk. The patient is in the focus, and on the other side, there's a topic regarding sustainability, regarding efficient resources and environmental protection. And that's why we're looking here for new solutions. And on the right side, we see here how such a process chain can work. Here at the topic in more detail. So we have on one side the collection, for example, in the hospitals, but we also want to introduce the doctors in that topic. We have a cutting of the waste, we have a sterilization, we have a separation, sorting, and afterwards a preparation of the material to bring that back into the value stream afterwards. And we have here different questions where we're looking for solutions. For example, how can be the pre-sorting in the hospitals or in the at the doctors? What are the best conditions for the crushing? For example, which size of the plastics will we have for the sterilization? Which size is the best one for the sorting afterwards? So there might be a conflict between that because the machines have different parameters, which are the best one for that and which makes the process more efficient. We have to look for different foreign substances who should be removed, what is the best sorting method, and at the end, what is the final life cycle assessment, what is the impact on the environment. When we look after the collection, so there was several projects, so one with hospitals, one with doctors, one at human-based healthcare, one at animal-based healthcare. So we are working with both directions. And for the crushing and sterilization, there are already some mobile systems available which can be used. So there are companies which sell this equipment to recyclers or sell the equipment to hospitals so that you can do directly that at the hospitals. But the current topic is mainly that afterwards there is no recycling of the plastic. The only idea at the hospital is that they can increase, decrease, so that they have to pay less money to the recyclers when they do the sterilization at the hospital itself. So they have to pay definitely do that the recyclers take the waste, but if they do the sterilization, they have to pay less. And here we made some tests regarding loading, cutting, which is vacuum generation, which kind of shredder should be used, what is the best pressure. Currently, there are two processes available from the Robert Koch Institutes, so they are certified and can be used by every company. And we see here on the right side an example. So we do a manual fill of the sterilization system. We had around about the temperature of 134 degrees. So that's a very high temperature. So there is a problem for many of the plastics that they melt. You see here on the right side, they melt together, so it's not that easy. There are also lower temperatures available and allowed to do the sterilization, but they have a longer duration. So it's always a compromise. How long is the duration? How much does it cost? Or will you have a fast process and you use a higher temperature? And here we see how is afterwards the separation and sorting working. So it's always the same. So we have some parameters which we see on the left side. If we have a high or a low belt occupancy, if there is at the end less material on the belt, which feeds the NIR system, then we have a higher purity. If we have a bigger amount on the belts, then we have at the end a lower purity. So it's always something like to find the best combination in these processes. And what we also did here, we had the focus on special these, what I've mentioned before, 70% of the plastics belongs to the group polypropylene, polyethylene, polyvinyl chloride, and that's why we also focused these materials. And here we see there are different possibilities to work with the system, the infrared system, and what is the sorting quality at the end. After the sorting, we do the regranulation and preparation for materials. We analyze the materials regarding the different material properties. We do tensile tests and so on. We have here also high pressure injection production, like we have seen today in many other projects. And we have analyzed the material properties, which comes from the waste from healthcare industry. And like we see here, On the right side, the tensile strength and the modulus of elasticity is lower in comparison with primary products, which are in light gray. And we see here polypropylene waste, which is analyzed. But we also see here that the giant elongation due to the mixture we have is more than the double of the primary material. So there is still a place for the optimization. And we see here during the differential scanning calorimetry that there are additional peaks, and that shows that, for example, polypropylene is mixed with some high density polyethylene. So there are definitely space to improve the material at the end. What we also did in one of the projects, we produced a demonstrator, and due to the fact that we also want connect different branches. Here it's a vessel for water purification. So we want always to find a solution which can be afterwards on the market. But there is also the possibility to increase the material properties with some additives, or to have recycled glass fiber inside. And that's why afterward it can directly be used at the same application which we have. Okay, so here only a small summary, which I've mentioned before. So we have currently the extended producer responsibility already in Germany for special areas, but it shall be extended at the end. And there are some solutions available also where we have no downcycling. So always it's depend how the products are designed, which I mentioned with the example from polymer parks. We have definitely not only the focus on the recycling, there are so many solutions considering all the 10 Rs. Which also been here like repair or repurpose or something like that. And it's definitely worth to look at the healthcare industry, because all of them generate a lot of waste, and there are some solutions already available, but we have to bring them into the industry. And maybe it's worth also to consider this whole life cycling and to consider the different fees they have, because if they have to pay less at the end, if for the recycling, it's worth to have special solutions for that. So that's from my side. And if you have any questions, I'm happy to answer that. But thank you for the attention.
Thank you very much, Mrs. Kroll. Do we have any questions? No, from the online participants? Also not? Yes, I would just like to thank Mrs. Kroll for totally another perspective on the healthcare industry, which goes far beyond traditional patient-centered focus. And all of us need to reflect twice on buying and purchasing single-use plastic. Well, that leads us to the final masterclass today. I would like to welcome online Professor Edita Vujasinovic from the University of Zagreb, Faculty of Textile Technology. Textile have been mentioned today several times, but in the previous masterclass was also mentioned within the Extended Producer's Responsibility 2, which tackled the textile. So I would like Professor Vujasinovic to share her presentation and to speak about how to innovate in textile without compromising recyclability, and is it possible? Mrs. Vujasinovic, Dr. Professor Vujasinovic, the floor is yours, please.
Thank you very much for such a nice introduction. And this is the part I will skip for now on. At the beginning, I want to say hello and good afternoon to all of you that are in Zadar now, and to all of us that are online with a little help of technology. I would also like to take this opportunity and thanks to the organizer for the opportunity to introduce you our magic world of textiles, hopefully in a completely different way than you expected. The title of my and my co-workers' presentation is The Paradox of Progress, Innovation versus Recyclability and in Textile, and it summarizes almost all difficulties that people dealing with the textiles are struggling for thousands of years. It also indicates that every innovation carries the potential for unforeseen problems, as initial benefits can lead us to the new challenges, like today's solution can become tomorrow's problem. And okay, sorry, this is technical problem. I need the next slide. Okay. Textile is perhaps one of the people's longest lasting and best known material invention. And for more than 3 million years, textile and clothing have played a vital role in the development of human society and have had a profound impact on the way we live our lives. And although next slide, please. Although, no, not that, the previous, yeah, thanks, this one. Although initially, textile and clothing were intended as protection from the cold and harsh environment, over time, clothing became a sign of civilization. The need to beautify appearance and emphasize aesthetic function, which emerged later, influenced frequent changes in style and the fashion establishment. At the same time, textiles have become a way of differentiating, whether by status, gender, interest, and today's textile, either combined with sophisticated electronics and or through specially designed materials, transform our everyday clothing into smart ones capable of interacting wearer with the environment. On this historical part, we have encountered different textile fibers and materials, paradigm shift, demands, intelligent and practical solutions, but also challenges in how to preserve the earth for the future generation and remove the stigma from textiles as one of the biggest polluters. To overcome these obstacles, we need to look into the past and consider whether our demands on textiles today are achievable in a sustainable way. Next slide, please.
Vi imate kontrolu prezentacije, možete kliknuti samo lijevo ili desno strelicom. Vi imate kontrolu prezentacije. Hvala.
Hvala i vama, nismo uspjeli, probat ćemo nadalje. Hvala. So let's go on. When our development route began, million years ago, the motto, take it from nature, prevailed. Clothes and shoes were made from materials that were all around us. It was fur for Eskimos, leather fur and natural fiber for Aussie snowmen, silk for Chinese emperors, cotton for pharaohs, linen and goat hair for slaves, wool for Romans, Vikings, and Dalmatians, and so on, all over the world, depending on the geographical affiliation and autochthonous plants and animals. It was an era when, through the mechanical recycling of textile and cloth and their final biodegradation, and the essential, not excessive use of natural resources, people planet Earth and profit were in harmony. After many years of evolution, nature came up with ingenious solution that we found all around us. Among first who understand this was a great artist and scientist, Leonardo da Vinci, and his motto, copy nature and be inspired by it, is still valid today. However, only the development of science and technology enable us to copy nature, not only through the creativity of designers, but also through engineering solution. At the end of 19th century and the beginning of 20th, the first artificial fibers were born. While designers were creating fashion trends, engineers developed the process of spinning artificial fiber as well as the nozzles, which enabled us the development of so-called first generation of man-made or artificial fibers. These were fibers made from wood cellulose, algae, rubber from rubber trees, casein from milk, and polysaccharides from corn. It was an era when through mechanical, sorry, I was too quick. It was an era when through mechanical recycling of textile and their redesign, the use of natural resources and humanity were in harmony, and profit became an additional motto. In the mid-20th century, we understood the richness of nature, mastered new knowledge, techniques, and technologies, understood polymers and polymerization, and as a result, a large number of artificial fibers from synthetic polymers were developed, starting with polyamide, polyester, polypropylene, polyethylene, and so on. So-called synthetics were created, which made our lives much more easier, at least in the domain of ironing, drying, washing, but it also opened to us the door for the era of technical textiles. However, in addition to the aesthetic characteristic of textile and their functionality, people begin to place emphasis on targeted efficiency. So we begin to modify existing artificial fiber of the first and second generation and create new fibers with improved and or modified properties. In addition to the molecular level modification were also carried on the morphology of the fibers, which is responsible for numerous properties of textile, such as shine, drape, color, cohesiveness, friction, selective absorptivity, and so on. So the third generation of synthetic fibers were created. However, the human desire to research and to find something new did not stop. We wanted to explore the space and, of course, step on to the moon. And then fiber engineers and textile people, like everyone else that are involved in structural materials, begin to think differently and look for the inspiration and solution in nature. Nature as a model, measure, and mentor become the new motto. New instrumental techniques gave us an insight into the structure of matter and help us to explain how it works. So attempts to replicate such structures created by nature through architecture, sports, protective textile were followed. A new fifth generation of synthetic fibers, or so-called high-performance fibers, was created. These fibers enabled us to build a rocket to go into the space, step on the moon, take photographs on the Mars, and at the same time on Earth, we moved faster, entered fire, swim in the frozen sea, and so on. However, new fibers were not enough. A new textile construction was also needed. And the answer was fiber-reinforced composites. Fiber reinforced composites is a textile that usually consists of two components: high performance fibers as a reinforcement, and they are embedded in metal ceramical polymer matrix. Given the possible number of different combinations, having in mind the number of fibers in different matrices, fiber reinforced composites have conquered the world. We get faster car, airplanes, spectacular buildings, top sports result, and of course, finally entrance in the fashion world. This kind of thinking and products and progress in textile materials has led us to the fact that textile become present everywhere around us. And according to this picture, it is visible that almost the smallest quantity of it is intended for clothing or conventional textile. The era of technical textile has prevailed, functionality before aesthetic and profit above all. The end of the 20th century brought us revolutionary changes in science and technology with an endless impact on our lives. The human genome was discovered and decoded, computers and the internet invented, and ecology became an imperative. As always, textile workers had responded to the challenge. Naturally dyed and organic cotton have appeared on the market, as well as lyocell fibers. Citric acid has replaced formaldehyde-based cross-linkers. Natural dyes have become trendy again, and enzyme, microwave, and plasma treatments become promising treatments for the 21st century. To sum it up, we can say that the concepts and technological solution to preserve or save our resources and prevent environmental pollution were being found. So at the end of the 20th century, two directions of action were defined, the so-called green production and eco-design. However, eco-design of products proved to be a more complex challenge. Its potential ecological and economical effects or advantages went far beyond the reach of manufacturers and required the mobilization of the entire society, more precisely all of us, which of course did not happen. And as an example is this slide. Although we have become aware of the many negative impacts of high performance and multifunctional textile, we are not yet willing to sacrifice our comfort and the benefits they bring to us on the account to preserve the planet. And disposable baby diapers is one of them. In addition, the situation gets worse at the transition from the 20th to the 21st century, when ICT technologies entered all spheres of our lives. The motto, make it easy and less time consuming, became in. In the field of a textile, it was a signal for interactive and smart clothes and fibers of the 5th generation, so-called smart or intelligent fibers. The desire to handle current and accurate information at all times has encouraged us and encountered the development of wearable electronics or e-textile in the form of so-called motherboards for soldiers, clothing for chronically ill patients or top athletes, or let's call it fancy clothes for our favorable Generation Z. On the other hand, new fast-change materials incorporated into textile could cool us and warm us at the same time, and that was particularly useful in the space exploration. Although started from the imagination of writers, filmmakers, and researchers, efforts to obtain invisible cloak have gained attention primarily for military purposes. So-called metamaterials are being developed which due to the specific architecture of the surface deflect the light rays around such, them making them invisible. This science friction is becoming reality, but not yet in our home and in our closet. By incorporating nitinol into clothing, we forget ironing, have possibility to change the appearance of clothing, through which we support the increasingly present trend of slow fashion. And finally, by clever copying nature, we have created chameleon fibers to support the oil industry as well as the medicine and sport. But driven by the pursuit of profit, we forgot that we have duty to predict how to dispose such interactive textile at the end of their life. And here you may see some possible recycling and disposal channels for e-textile, and none of them is good. And we have to be very carefully and very innovative, because this market is growing from year to year. And last year, it was estimated around $5 billion. And then came the 21st century. We looked back this time from the space and asked ourselves what our future will be and how it will look like. The Earth is overcrowded with the humans. It's surrounded by space waste. The ozone layer is damaged, and the Earth is covered in waste, while natural resources, at least some of them, are being irreversibly destroyed. So, how the textile of the future will look like? And the answer is not so simple. If the future is oriented exclusively to the conquest of the space and our settlement in it, then the answer is yes. Textiles will be new and based on smart and intelligent fibers. However, if the future is not if the future is survival of the human species on Earth, then the answer is no. Textile will not be new. The new are sources of raw materials. That our way to the future depends on the return to the past was realized through the United Nations decision to declare 2009 as the year of natural fibers. Forgotten and abandoned Spanish broom, hemp, and bamboo fibers, as well as spider silk, sea silk, and alps, have been revitalized. And of course, something that we become aware is waste and bacteria. So we said, okay, let waste become the raw material of the 21st century, whether it is agro waste, waste from the food or consumer industry, and of course, the textile industry. New or improved recycling and recovery models are being invented, and sustainable design starts to get more and more attention, which is in line to the need of new composites, and that were biocomposites and their creation. That biocomposites are a trend is shown by numerous groups of scientists and their projects, both all around the world and as well as in our country. With an interdisciplinary approach and a return to the learn from nature trend, biocomposites are being designed from energy sustainable resources and ecopolymers. And nowadays are used in the automotive and construction industry, the furniture industry, even in the production of musical instruments, However, we are still missing something. And what is it? Can be read from the answer of visionary Steve Jobs and his answer to the journalist who asked him what will be the biggest invention of 21st century. He said that the biggest invention of 21st century will be the intersection of biology and technology. Although we achieved some of this synergy in textile 30 and 40 years ago through naturally dyed cotton obtained through genetic engineering, it was not until the 21st century that biomimetic textile and the concept of biocouture, tissue engineering leather, biosuits, and biogrown textile were introduced into our everyday lives. The next blue slide will reveal what is the secret behind that. And I may say that the keywords are genetic and bioengineering in synergy with the fashion industry. To combine crazy science with textile production, designer and researcher Carol Collette has launched a project that aims to create natural textile through unnatural means. The BioLace project is set in the future of 2050, when genetically modified and engineered enhanced food is grown in greenhouses with sunlight and water, and in addition to harvesting fruit. At the same time, from the same plant, fabrics would also be harvested. This inspired another designer to 3D print a sneaker from the synthetic biological material called protocell. And in addition to being the right size, these sneakers would react to changes in the running surface by modifying their thickness and hardness. And at the end of the day, they could be regenerated by placing them in a container with the same biological material. Today, many young, ecologically aware and creative textile designers, through an increasing number of startup companies, strive to combine their creativity with science by working in interdisciplinary teams to create new textile for the 21st century. One of the successful examples is bioclothing, which at the same time fulfills aesthetic component, basic primary function of clothing, inform us of the harsh environment where we might be, enable us at the same time purification of the air that we breathe. In this way, the multifunctional effectiveness of textile is achieved in a smart way, which contributes to the reduction of ecological footprints of such garments. And if we learn from the experience, and if we apply the life circle thinking philosophy along with the development of new textile, we consider also at the same time to reduce the negative impact of new textile on the environment. Some of the offered, but still not realized, completely creative solution envisaged a 3D bioweaving and laundry and recycling in one. So to summarize my thoughts and this presentation, I may say that as the textile becomes smarter, the question arises, are we truly advancing towards sustainability, or are we weaving innovation that future generation will struggle to recycle? And after all I said, I think that all of you realize that the 21st century brings us many new textile, and such kind of a textile can be achieved only through the synergy of science and creativity. So through the sustainable engineering approach and creative thinking, we may produce textile that will fulfill all the requirements: ecological, aesthetic, functional, multifunctional, effective, and so on. And having perceived the advantages and disadvantages of new generation of genetic and biotextiles, and the positive and negative implication on our life and the environment, instead of a conclusion, I will leave to each of you to make your own judgment and decide whether you will in the future support well-promoted marketing brands and designers that use genetically modified clothing, or perhaps ask yourself what I am actually wearing, or have we crossed the line? Thank you for your attention. And of course, is there any question for me, please do not hesitate to ask.
Thank you, Professor Vujasinovic, for such vivid and informative and inspiring presentation, who took us from the history of textile through the origin of the textile and how to use it in a sustainable way today, especially how the textile industry and the engineers now shape and follow sustainability road all the way from the space odyssey and back to the natural fibers and biocomposites. It's a long way, and I think we should all think about what we're wearing and where it's all going. Thank you very much once again. Do you have any questions maybe for Professor Vujasinovic? I would like to remind the participants online you also have the opportunity to ask. If not, with these lines and the last presentation from Professor Vujasinovic, I would like to conclude our masterclass closing the loop session. Thank once again all the speakers online and the speakers here in Hotel Colovare, all the participants for now. Welcome back to the afternoon sessions. The last session of today is going to be dedicated to two interactive panels with a focus on the project results. One was dedicated to the green transition in factories and the other to the launch of the Circular Innovation Academy, which you will hear more about a bit later. So back to panel one. Here I would like to give the floor to Mr. Alen Draganovic, who is going to moderate from Tekos Slovenia, and his guest, Mrs. Katrina Sliva, Chief Executive Officer from the Ergo Design Company from Poland, and Evelina Cha, Head of the Sustainability Consulting, also from the same company. Alen, the floor is yours, please.
Thank you. So just to say or to also present to our my colleagues here today, I would just like to have a short introduction to our pilot factory. So how we as a consortium talked about it, how did it came, so that you see that you when you started the piloting where we were before that. So as agreement among us partners, we said that we want to make pilot factories. We agreed among partners that we will have each partner 2 pilot factories. So one will be cross-sectoral service factories for SMEs, and the other will be for sector specific. And we decided as partnership for which, so like construction, textile, ICT, and electronics. So the goal was to make circularity practical, profitable, and repeatable across Europe, as we all agreed. And we started. It was a hard work, but we did it, as Agnieszka always said. How was the piloting built? We did it before. It was built based on interviews. So with the interviews with 60 companies, we got information from it, especially from these 3 sectors, so that we get the sector more. And then from there on, we built the pilot. And one of the pilot was also the Tekos pilot. So I will just present shortly. Vesna already had Tekos presentation. Ours was purely based on fast prototyping. So how to keep SMEs to have a faster to market or test product and then go to market. This is something that Tekos normally does, but was also involved here. So the idea was to have it fast prototyping with in the electronic sector and cross-sectoral pilots and cross-sectoral companies. And as all partnership, we all published a call. So it was an open call so that SMEs could apply. And Tekos offered this kind of fast prototyping, so from plastic materials, packaging, prototyping, injection molding, and eco-innovation, something that Vesna already presented today. one company, startup company, that was really a good one, good example, Exaplast.io, applied. They needed a new model for pressing composite. We did it like in 3-4 months. It was very helpful for them. We also, let's say, co-financed their needs that they did it, and it was a perfect example how this kind of, it's a two-person companies, 25 years old people, startups that need this kind of support. And then afterwards, there were some questions or conclusions that this kind of prototyping is really needed, especially for the startup companies. And looking at Slovenian level, not only the European level, we want this to have this kind of vouchers more. So, and for example, in Slovenia, this kind of voucher for fast prototyping was 4 years ago, and now probably next year will be another one. So in 5 years, there was not a lot going on in this kind of supporting fast prototyping, and we wanted to be more and more. So this was our experience at Tekos. And similar experiences were also among other partners. So we all had different piloting. And even now, when I was preparing the presentation yesterday, I see similarities across us and possible joinment of our pilots among us. You can see that LCA is mostly all digitalization and so on and so on. So there are connections among our pilots, something that we will also talk on our meeting tomorrow. So how can we, from these pilots, go on, work together as a Europe together joint, so that we not just locally have them, but also in a European level. Yeah? Okay, and this is a short presentation of just how we get to your pilot. So now I would like to give you the word to present your pilot and show us how did you do it in Poland.
Thank you very much.
Yeah.
A warm welcome on behalf of our design studio, Ergo Design, based in Krakow. And we are here very pleased to be here in person on behalf of and on the request of Krakow Technological Part. So we are a technical partner who supports building methodologies for Krakow Technological Part, and also our final task on the journey with Smart Circuit project is developing and implementing of the pilot project. And our industry was packaging for food industry, but we were given a very small, very local company to work with. And I would say that if you want a total overall transformation of a company, the bigger is more difficult. But if you want implementation, the smaller is more difficult, because scale of resources and a very direct contact with people that are creating this company, this is something that requires huge skills on the side of the design company as ourselves. So we'd like to share, hopefully within 10 minutes, a short presentation on how it was going and what's the transformation towards circularity for small and medium-sized enterprises looks like from our perspective, design company, actually a circular design company. So we'll talk just a little bit about how our mission as a design company changed, and the change in our approach, because our service offer changed totally, and we have a three-way approach towards transformation of small, medium, and large companies, and about circular change by design, actually eco-design, which is a story about our small local ice cream manufacturer. So it's going to be a very sweet and cute story. And I myself, I'm Katarzyna Śliwa. Kate Śliwa is as good as well. And I have the role of a CEO at our design studio. We have around 20 people. And today with me is Ewelina Cha, our head of sustainability services. Ewelina will actually take over in a minute to share the case study, because she was in charge of the client and the project. And actually, I would like to pinpoint why we were chosen as a technological partner for Krakow technological part, sorry. Actually, that's because we are probably the longest continuously operating design studio, definitely in Poland, but I would dare to say that probably in the Central and Eastern Europe, more than 30 years of and 3 generations of industrial designers, strategists, engineers working together. But after 3 decades of actually focusing on generating innovation, innovative know-how, innovative products for our clients, recently we came through our own circular transformation. And around 2019, we started to promote circular economy among our clients who are manufacturers, service providers, actually all sorts of companies from absolutely all industries possible. And we also started to pioneer development of eco-design methodologies for the design industry. We have some open source tools available at our website. Here we worked more like a classical business way, but you'll see in a minute. And thank you to Capeta for inviting us. You were really wonderful in this journey. 3 years of hard work towards greener business in our region. We were just a small part of that. So thank you, Agnieszka. Thank you, everyone on the part of Capeta. And coming back to what we do. As I said, we have 3 major green, let's say, services. The first one is actually currently the most popular one. It's an overall circular transformations of companies, mostly medium and large. Most of them are manufacturers. And what we do here, we go through a 12-week extensive audit of business model of all sorts of processes that are ongoing in the within the company of the client. But what clients are looking for here is innovation in processes to economize, to cut expenses. On the side of buying, on the side of waste, it's not going too far into the income part, which is, well, we're working on that, let's say. But within the past 2 years, we've completed more than 40 such projects, which is a lot, which is really a huge amount. And we're going towards the implementation phase with our clients nowadays. But this is not a service for everyone, mostly medium, large, mostly manufacturers, mostly companies that are ready for a total makeover with possible huge investments. So most of them are still EU funds in Poland. It's not working. No. Next slide, please. Thank you. But the second, our service is also focusing on the business side. But here we work on business models in more focused way. We work a lot with startups or spin-offs. So something that we share. Yeah. Yes. So they come to us with their business ideas, and what they expect is design, product design, service design, process design, and the design of a system within all those products, services, processes work, which in our case is circular business models. And here we design for durability, future compatibility, multiple remarketing, lengthen product life cycle, such stuff like that. And here, our clients are more focused on the income part. Actually, very few of them are manufacturers. They're tech companies that are looking for their technology to be commercialized in products and services. And finally, the last but not least, as an industrial design company, we are very eager to design, but within the context of product and service lifecycle. So, here the story is a little bit more complex, but this is a service where very little changes and very short projects can lead to really huge actually results. For example, here you can see a spool for 3D printing filament. that actually over the course of the design process, the material usage was limited by 27%. But it was not to the detriment of usability, functionality, aesthetics, so market value. The opposite. Actually, at the time of the implementation, which was a couple of years back, our client, Fibrology, was probably the first manufacturer of 3D printing filament that were offering also multi-usage spools for their actually product that is, you know, fast-moving consumer good. So that's a no-brainer actually, as in terms of eco-design solutions. So before you do anything else, reduce. This is story. This is the case study, but you know, leading to something that is really actually translating, yes, and building the market value of the product and the consumer. So to sum up, we have 3 major approaches to circular transformation of our clients. 2 are more business-minded, 2 are more design-minded, but definitely eco-design is a service, something that any company can do. Even the smallest company can do a project that will spark actually the learning curve about what's possible and what are the benefits of circular economy and, you know, considering environment in their business activities. And maybe we should move towards our case study. So over to you, Evelina.
And can you hear me well? Yes. Okay, sounds good. So again, Evelina Cha, Head of Sustainability Consulting for Ergo Design. And so the case that I want to talk about is the case of Lody Dudzik. Dudzik Ice Cream, a local manufacturer in the southern Poland, close to Krakow. The company was established in 1971. So over 50 years of selling delicious, natural, local ice cream in that area. And they have been in the same location during that entire time. And Lody Dudzik came to us through Krakow Technological Park. And Agnieszka and the CEO, and they said, what we would like to do is to develop a circular single-use packaging for ice cream. So we will we'll talk to you about the eco-design catalyst for strategic growth and how it worked out specifically in this case, because the pathway to that circular economy and that growth for a company may not always be as straightforward one and as direct as we would imagine. So again, they came with an initial goal. We went through the process of strategic discovery, and then you're going to see at the end the final outcome. So they came with a very specific idea in mind, but our maybe I'll go back for 1 second. Our team said, okay, we really love this idea, but what we always do is we do a strategic discovery first. Why? Because you can imagine that during the 30 years of Ergo Design work on over 1,200 different projects in their 30-year history, there have been many situations where a client came and said, I want to design this. The company designed that for them, let's say, and then a year later they said, oh, this is actually not fitting my market, my customers, maybe we should have done something else. So the company has focused, Ergo Design has focused more and more also on strategic advisory. And so our team immediately said, that's a really great idea, but let's do a strategic discovery first, okay? So number 1, just a basic business model, key partners, proposed values, customer relationships. That was kind of an important part of that, because we have discovered during that phase that this company really has very strong relationship with the local customers, but maybe there is some room to grow further, okay? And CEO's vision, he had actually pretty well defined, and this exercise helped him to further crystallize that and define that in his own mind and for us as well. And then we moved on to the brainstorming session. We had the CEO 3 people from Krakow Technological Park, and 3 people from the ergo design team. And as you can see on the right-hand side, there's the disposable single-use packaging right there as an idea that was popular. On the left-hand side, you have another idea, reusable packaging. What the CEO was talking to us about is that many clients come with their own thermoses still. They want to take ice cream home. So instead of buying maybe lower quality ice cream in a 1-liter plastic container, they actually come to this place with their old thermoses. They want to take ice cream home. It's just that these thermoses are not very comfortable because they're the tall, long ones, and so it's kind of hard to dive for ice cream in it. And so in the brainstorming session, we had a lot of ideas that focus on the locality, on the fact that this particular company as an ice cream place is a place where people come, gather. It's a place for families. It's a place for building memories with families, friends, and so on. So there were a lot of good ideas. And then we did a voting system. Everybody had 2 votes. And disposable packaging, you guys, the single-use disposable packaging that they came with initially, it got 2 votes. Whereas the reusable packaging, so a new form of some kind of a thermos, got 6 votes, was the most popular idea. And that was the CEO's favorite idea. So as you can see very clearly, the idea has changed from single-use to something more durable. And so there were many more slides in our presentation and throughout our work with the customers. I'll just show you a snapshot. We have created like 14 different versions of what the final packaging could be, considering that the CEO wanted it to be more or less circular, or most circular that we could come up with. And the CEO decided on a steel plus 3D printing. So our team has designed this packaging with the logo of Lody Dudzik and the ice cream patterns, as you can see, ice cream handle on top, to create a very kind of a sentimental and ice cream focused solution, and customizable. This is a magnet that you can take off. Inside you can print the name, so you can give it to somebody for a birthday, or you can put best grandma, best Father's Day, and so on, best dad. So you can you have a combination of circular, durable packaging with while creating a very strong emotional connection for a person who gets that packaging with their name on it. And there is the brand name of the ice cream place to help the company grow that connection with their customer base. And I have asked the CEO, can you give us some takeaways for you from this project? I didn't ask him specifically what I want. I said anything that that you got out of it. And he said the key results for us are a unique product. We have created packaging that is functional, aesthetic, and in line with our company's spirit. It will increase customer engagement, and it's responsible development because we want it to be circular. Our next steps will be to create a coherent series of products, so maybe a smaller one, maybe a larger one, to kind of create like a little family of ice cream packaging, eco-friendly alternatives. So he absolutely long-term wants to do the eco-friendly single-use circular packaging for ice cream, right? But that's as a next step, a little bit longer time perspective. And he wants to implement a loyalty program because he does have a strong customer base, but during the discovery process, we have discovered that there is just so much more potential. There's people coming from outside of that area that already like this place. If there's loyalty programs implemented, they can really grow their business. And here's 2 more things that I wanted to show you from Marian Dudzik, the CEO of Lody Dudzik. This collaboration opens up a new chapter for us. The reusable packaging project is more than just a new product. It is a proof that our tradition can go hand in hand with innovation. And number 2, Thanks to this collaboration, we looked at our brand from a completely new perspective. We learned how to develop ideas in a thoughtful manner and turn them into real, valuable solutions for our customers. And I think that what we have seen with Marian Dujic, the CEO of this company, is the level of confidence that he has gained thanks to this process, because he now, number one, he has realized so many things about his business. So again, the discovery, putting things in writing. And so the main takeaway from this is, as you guys have noticed, he came with a different idea. The discovery process took him to a different choice. So when we have a problem, the pathway to the solution, if there is a proper framework, discover, define, develop, deliver, and there's a process and tools attached to it, then something really tangible can come out of it. And I would like to end with the quote from the research from Ellen MacArthur's foundation. 70% of the product's environmental impact is defined at the design process stage, at the beginning. So not thinking about recycling, but thinking much earlier. And kind of the same is for how are we gonna go the circular pathway, taking it a few steps back and just starting at the very, very beginning, thinking about who the company is, their strengths, their limitations, their resources, and then building on that.
Like a reset, huh?
Yes, like a reset in a way, yeah. Thank you so much.
Yeah. Wow, applause, please. Yeah. Yeah. So it was better to listen now to you and then have questions, because now I have new questions and new questions and new questions, but unfortunately I can only have 2 questions. Let's start with our together point with working with startups and working with companies and so on. So I get the medium companies wanting to lower the costs and having this economical value to them, so to change their circularity. But what about the startups, the new companies? How do they take about, or how do they value that, and how could you help them? Is there any funds for that, or?
Yeah, actually, we have many startup clients who are actually companies focused on the new possibilities, new markets, new product categories that circular economy actually brings with itself.
Okay.
So we have startups like medical startups. They're technological focused, yes, and we develop I don't know, services, machinery, actually systems to bring their technology to actually people, to users.
Yeah.
And on the other hand, our sustainability startups are the companies that are actually built in absolutely new categories of business. For example, we are very proud of our clients, Masloop, who are developing reverse vending machines and actually glass and plastic crushers and crunchers for a couple of years. Actually, lots of millions poured into this company, years of financial losses. And this is the year 2025 when they first saw some revenue. And it's going to be 20 or 25 million euro this year alone. So a big start. And how it happened? Actually, they were anticipating trends, anticipating legislation, actually obligations. Because on the 1st of October, the system for exchange of the plastic waste, plastic bottles, plastic packaging is implemented in Poland, actually. So they were getting ready with really mastered technology of management of the system, of management of data, because the hardware is a very small part. It needed to be reliable, working, very cheap to produce in huge numbers. So this is the story of Masloop, who is really a champion of,
Yeah, thank you. So we can say, because this was my question, you got it. So is it, could this be applied in Europe? So in other countries, in Slovenia, for instance, in any other country in Europe? And I think it is, because the policy is the same, European is the same union, so we have the same rules. And if startup wanted, they can use this.
Of course, yes, definitely.
And now the second question is about the tell us more about the project. So, okay, we heard about the company. They had the reset complete. You had sessions with them, and always this brainstorming ideas. I get it. What about the customers? How was their reaction? What do they feel?
They will actually be only implementing this now. We just finished like a month ago.
Okay.
So yes, we were working on short timelines, and so they will be implementing it now. So
how will you test it? You will analyze it, or
well, that's probably next stage with the CEO. He now wants to bring the packaging kind of to the to the store and devise a strategy of the loyalty program. We talked a lot about like involvement of the community. You know, if it's Grandma's Day, maybe organize something and so on. So just the number of ideas that came up during that time, and also involving getting involved with local schools, because at that place they have some old equipment that you can imagine kids haven't seen at all in their lifetime, equipment that is, you know, 20, 30, 40 years old. So having kids from a technical school come in and be able to see that together with a very modern equipment that they also have. So there is so many ideas that were generated to help them bring more people and help them build that attachment to that particular place.
Yeah, good story. Like after so many years that they want to build more and more and more and be successful. It's a good thing.
Actually, for a couple of years recently, they were chasing new materials to make this disposable packaging. You know,
but from where was it raised? From a new generation of family employees, or from the
new generation?
Yeah.
Yes, drinking from Italy some innovative material and processing it, and they're a little company, and see that, you know, tradition, long years of existence, customer based, loyal for many generations. These are completely different values than disposable packaging. So that turnaround, like 180%, you know, degrees towards the, you know, durable, circular, multi-use of packaging. This is something that completes their business actually. Yeah.
That's great.
Yes.
Yeah. Thank you for sharing the story. One applause, please. One again. So yeah, we should continue. Yeah. Or does anyone have a question? Or yeah, one question. Oh, short, but really short. I will give the microphone. Okay, I'm assistant as well. Yes, please.
Thanks. I want to ask, how do you in general measure the environmental impact? Because you said, and I agree, that the biggest impact is in the eco-design phase, but it's a tricky part to measure it, especially when you switch from single-use to multi-use. It's a lot about the use phase, and I know that the single-use cups, for example, if you switch them for stainless steel, they need to be used at least 100 times to be break-even even. So yeah, how do you measure it?
Well, I guess, and that's where LCA again analysis comes in. But I'm not sure that, you know, I'm not sure that, well, 100, if it's a steel cup, you're mentioning 100 times, I think a steel cup will be used many more times than 100 times. So I think it's a winner right there, definitely.
Actually, we always build like qualitative circular analysis of life cycle, and then we put some hotspots and then like bring numbers for like quantitative analysis. So we are not at this stage with this project, but it's always about LCA. And with the circular business models and the makeover of the production processes, we have really a huge amount of metrics that are measured to compare before, after, and before. Yes, so everything is measured here, but you need to have a strategy. What's important? Yes, and probably the you know, material here is not as important as the life cycle as a whole, yes, and for the product.
And if I can also add one more thing, right now we're still in a very much transitional stage of developing circular solutions, right? So when we're looking at the LCA right now and comparing, let's say, a plastic to some other solution, we can say, oh, looking at the LCA, this plastic is actually more beneficial. But it's because technologically we haven't gotten yet to where we're gonna get in 5 and 10 years. So the time limitation that we're like of having been developing circular solutions only for 5, maximum 10 years, really, that is the challenge. In 10 years, we're going to be in a very different situation, and that LCA will look very different. So looking at the outcomes of the LCA right now doesn't give a full picture of what will be 10 and 20 and 30 years from now, and that's obviously what we're focusing on, right?
Great, thank you. Okay, one more applause and then new panel. Thank you very much.
Thank you very much, ladies from Ergo Design from Poland. Now I would like to welcome Alan. Please stay a little bit longer.
Yeah, I will be. I have to be ready for questions, so I'm here.
I would like to welcome Mr. Nemet Bence from BBN, Panel Business Network from Hungary, and his little friend Poppy here to see how green transition works with the robot. Yeah, Mr. Nemet.
Yes, thank you.
Yeah.
I just need a few seconds.
Should I be closer?
Oh, okay. So hello everyone, welcome. My name is Bence Nemet. I work at MLab PBN, and I was one of the engineers working on Poppy. She's a small humanoid robot. She, he, it, I don't know. Maybe she is a she. Thank you. So we have a production line at our company. I would like to talk a few words about this production line. It's developed by SMC Hungary. It's a modular production line which consists of multiple stations, and we also call it a teaching and learning factory. At the module 2 station, which is on this picture, many times there are some kind of problems, so we could try to solve these problems with Poppy. But she will talk about this part later, hopefully. So yeah, she's a small humanoid robot, and the white parts were 3D printed, and she is also open source. So she's also open source, so we can implement new solutions on her. And she has 25 motors and some kind of other features, and the camera right here. With this camera, we can do face detection and also object detection. And she also have a display. Yeah, okay. Which we use for the eyes, but you can also use it for like visualizing some kind of process results. I try to talk with her. Okay, so hello Poppy, please introduce yourself.
Hello, everyone, and welcome. I'm Poppy, and I'm excited to be here today with all of you. I come from the Smart Circuit Project, where my mission is to make manufacturing smarter, more efficient, and more sustainable. In this pilot, I am being integrated into the production line to detect and resolve material shortages at the Module 2 station. My goal is to reduce machine downtime, minimize human intervention, and contribute to a more circular economy by optimizing material use and recycling. I look forward to showing you how I work and how I can help improve the production process.
So unfortunately, she doesn't have any internal microphone or speaker, so we have to use these. First we assembled the robot and teach her some basic movements like waving or moving her head or something like this. Right now she has a face detection algorithm, so she tries to find faces and follow them. But if there are multiple faces, then she will just switch. After that, we integrated with our mobile robot, so she could go around the production line more easily. And we integrated with the production line and did some kind of computer vision algorithms for many tasks. And the last part was to integrating her as a production line assistant at the production line. So I would like to ask some questions. Just a minute. So, Poppy, please tell me how the production line monitors.
Hi there. Great to meet you. How can I assist you today? I am integrated with a mobile robot that allows me to...
How the production line monitoring works.
Of course. Let me walk you through it. I am integrated with a mobile robot that allows me to move autonomously around the production line at preset intervals or on demand. During these patrols, I continuously analyze visual and sensor data from different stations to ensure that all processes are running smoothly. I am able to detect various faults on the production line, such as misaligned components, irregular material flow, or equipment malfunctions, using computer vision and AI-based anomaly detection. When I identify a potential issue, I immediately alert a human operator, either through a message on the control dashboard or a voice notification. My goal is to reduce downtime, improve product quality, and ensure that the line operates efficiently and safely.
So sometimes she stops the movement because one of the motors overheating and she needs to be rebooted, but I won't do that right now because it takes like a minute. But I have other questions to her, so she will speak. How can you detect material shortages?
Great question. The mobile robot takes me to a fixed, predefined observation point from where I can clearly see the Module 2 station and its material storage area. From this position, I use a combination of color-based detection and object counting algorithms to estimate how much material remains in the containers or feeders. If the quantity of raw materials is below the predefined threshold, I automatically generate a signal or notification that indicates the need for a refill. This early warning helps prevent unplanned interruptions in production.
So sorry for the image quality. These images were taken by Poppy's camera and it is a low resolution camera. And we also have another application. And Poppy, please tell me how can you detect when the material spills out?
Sure. This error usually occurs on the opposite side of the Module 2 station during the material dispensing process. It often happens when the storage box or container is inserted at an angle, causing the materials to be released incorrectly. When this happens, I can detect the anomaly through my camera feed by identifying irregular patterns on the conveyor belt or the surrounding area. For example, if I see that materials have spread outside their normal boundaries, or that the box is visibly stuck, I classify it as a spill or blockage event. If the human workforce does not notice this issue in time, production efficiency can drop significantly. So I immediately send an alert to the responsible operator or maintenance team. My early detection helps prevent extended downtime and reduces material waste.
Okay, and I have also one question about what are you doing when you are not monitoring the production line?
When I am not actively monitoring the production process, I function as an intelligent production line assistant. My role is to answer any questions related to the production line's operation, safety, and maintenance. I respond to visitors, lay people, or professional engineers, adjusting my explanations to their level of understanding. I also support onboarding and training of new employees by explaining machine functions and workflow logic in an interactive way. In short, I bridge knowledge gaps and contribute to a more efficient and transparent production environment.
Okay, so she works with OpenAI's real-time API. It's like ChatGPT, so you can ask any questions at the end.
And do you use it a lot?
Yeah, we are testing her many times.
Yeah?
She asks different questions, and sometimes she is very funny. But
telling the truth, or?
Yeah, telling the truth, and sometimes she lies too. Not about the production line, but other things. For example, the weather. She is always lying about the weather. So she can't ask her that. And we also created an interface. This is a user interface, but it has many versions. This version is for testing the different movements of the robot. And if somebody comes to our company, they can interact with her easily without the help of an expert. So they can just push these buttons, and the robot will do these movements. And she can also give visual feedback, so we can see what the robot sees. And yeah, we can improve her in many ways, for example, the movements or other things, and we try to do that.
Good. Is this it?
Yeah, I think.
And I know that we said that I would ask her questions, but I rather ask you. She answered a lot. Just one question.
Yeah, okay.
How do you see the future of this? Like in 1 year, 2 years, what will happen with her? How more and more will she be involved, and so on?
So this robot, I think we can do like these object detection applications. For example, we have a storage area, not storage area, a warehouse area, and we try to teach her to understand if there is a storage which is in a right place or a bad place, or something like this. But unfortunately, she's very small, and it has.
But you will have new robots, so what will they do? The question, the future.
I think I don't know if humanoid robots should be in the warehouses or at the production lines. They are not made for that, but they are trying with this. But I think for some kind of applications they can be good. For example, these vision algorithms.
Good. Thank you.
I think.
Okay, we need to finish. Go on, huh? Yeah. Thank you very much.
Please say goodbye.
It's been a pleasure talking to you. I'm really happy to have been here in Zadar with you. Goodbye for now, and I look forward to helping again soon.
Thank you.
Thank you. Thank you. Questions, or that's it?
I think we need the next session.
Next session. Thank you very much, then, Alan, to you. And we would like to jump to the second panel. I would like to call moderator Mr. Thomas Kremsner from Forschung Burgenland from Austria to join us here. And he will introduce the new Circular Innovation Academy, which has been developed within the Smart Circuit project, and you will hear about the new modules and the experience of some of the attendees that have already been through the modules and their experience. So please, Thomas, the floor is yours.
Hello, everybody. Hello. Now the best part of the day, we will have a short quiz about circular economy, and we will see how much you know about it. And the 3 people with the highest scores will get some chocolate or wine. So please scan this code. You don't need to use your real name. You can use also a fake name. Just if you're under the top 3, then please say it's you at the end. People at home, unfortunately, you cannot win something, but of course, in the next partner meeting in half a year, maybe you have the opportunity again. So yes, I hope it's working for everybody. Okay, then. Is someone still logging in? Okay, everybody ready? Then we can start with the next slide. Okay. Yes, question 1 appears. 14 players are ready. So, what is the question? Answer quickly to get more points. Do you see a question? Okay, now is the question. Which of the following sets of R's are the part of the main 6 R's framework for circularity? So on your screen, you see the 4 answers. What is the correct one? Please mark the correct answer. You will get points if your answer is correct, and also the time will count. So please mark your answer accordingly. 5 people have already put in their answers. In total, we have 7 questions. So even if you haven't got it right, 6 more chances. So the right answer was reuse, recycle, redesign, remanufacture, reduce, and recover. 6 people have it right. This is from our Moodle course, so most of you are already users, so technically you should know it. So, but 6 more questions. Let's see. Okay, Miroslav, Nemo, okay. Okay, Miroslav, Nemo, and Dragonet are the 3 best answers yet. So, question 2. 12 players ready. Okay. We lost 1 player. I'm sorry to hear that. Okay. What does material flow analysis aid in circular manufacturing? The 4 answers are optimizing resource efficiency, promoting the use of single-use materials, decreasing resource efficiency, and ignoring waste generation. So this should be from the 2nd module of our course. Okay. 13 correct answers. You learned quickly. So, but we lost 1 player, unfortunately. Let's see. Okay. Okay, Miroslav again, Nemo and Dragonet. Okay, but nothing. Oh, okay. Boating make boat face. Okay. So next question. 10 players already. What happens to you? Okay. Which of the following is not an AI application in smart manufacturing? Using AI for predictive maintenance, replacing human employees, or optimizing energy consumption? 30 seconds left. Okay. Everyone has voted. Okay. 9 people have the correct answer. And now let's see the corrected chart. Okay, I think we have a new score. So Sebastian has entered the top 3. Congratulations. Now the 4th question. 12 players already. Okay. What percentage range of operational energy savings can be expected from implementing energy efficient design and technologies in construction? So basically, how much can you save in energy if you implement changes in your construction? Okay. Still waiting for 3 answers. Okay, everyone has voted. Great. 8 correct answers. Great. And now 1 person is back. So we have again 13 people. And if Sebastian is out of the top 3, Dragonite is in again. So the last 3 questions, everything can change still. What is the problem with the recyclability of modern electronic devices? They have better batteries. They have batteries that are difficult to remove. Manufacturers do not provide recycling instructions. Screens are too fragile, or they are too cheap to recycle. Okay. Let's see. So the correct answer was they have batteries that are difficult to remove. Let's see the new score sheet. Okay. Veronica has gained some points. So let's see. Nemo, Dragonite, and Miroslav are still in the top 3. Question 6. 12 people are ready. And you need to answer quickly. Which are the main advantages of the textile recycling process? Transversal, biological, technological, and social benefits, diversity, financial and educational benefits, or environmental, economical, technical, and social benefits? Answer quickly to get more points. Every second counts, okay? Okay, everybody was right. Good job. Yes. Okay. So does this change anything? Okay, Nemo, Dragonite, and Miroslav still in the top 3. Now the last opportunity. 11 players already. We lost 1 more person. I'm sorry to hear that. How does the resale strategy contribute to the circular economy? By disposing of used products or materials, by encouraging the purchase of new items, by reducing the need for new resources in manufacturing, or by accelerating the depletion of natural resources. 20 seconds left. 10 seconds left. Everyone is finished. Let's see. Okay, by reducing the need for new resources in manufacturing was the correct answer. Only 8 correct answers. So now the final result. Okay. Okay. Nemo is the winner, Dragonite the second one, and Miroslav the third one. So congratulations. Who is Nemo? Okay. Okay. You can choose. We have a prize. We have chocolate or wine. 1 wine and 2 chocolates provided. Chocolate provided by HGK. So congratulations. You have all the answers because you all participated in the Moodle course. Okay. The second one, who is it? Dragonite. Yes. Do you want wine or chocolate? Chocolate? Okay. So Miroslav, who is it? Okay. So then you have the wine. Thank you. So now, last but not least, I would like to show you a short presentation. I will be quicker and talk faster. So now I would like to show you a short presentation, a PowerPoint presentation about our Moodle circular economy. The first question I would like to ask you, another question, who of you has already registered to our Moodle course on circular economy? Please raise your hands. Okay. Okay, for those of you who haven't registered yet, today and now is the opportunity. During this presentation, I will talk a little bit theoretically about the course, and then we will have a short panel discussion about it. And afterwards, you will also see the Moodle course and be able to register today for free. So, let me see where the presentation is. Do need to click. Oh. So our Circular Innovation Academy has officially launched, and today I would like to give you a short overview of all the modules. I will give a brief description, and if some of the module owners today want to add anything, of course you can add that at the end after I have summarized everything. If you don't have to add anything, then that's also okay. Then I will show you the Moodle platform, and we will have a panel discussion of our first users. So let's start with what is the circular economy. So this is one of our main outputs. We have created one course on circular economy with 8 modules, and we want to teach how to use circular economy in your business. This is rather a beginner course, so it is the foundation, and then you can go deeper into certain topics that are interesting to you. So here we have the statistic of already registered users. So this is more of an internal user group that we have for testing, but now it's officially, now it's official. Everybody can join, and everybody at home can also join. I will provide the link at the end. And at the moment we have 60 participants. Our goal is to reach 120 participants in the project, but of course, the more the better. And yeah. Yes, these are all external. So what about the modules? I will give a short overview of them. So the introduction is the module 1 and module 2, and module 3 and module 7 are more tools for circular economy. So tools that you can use to implement circular economy in your business. And we have also 3 application areas. So construction, focus on electronics, and on textiles. So these are the 3 areas that we want to focus on. And module 8 is learning by doing. You have to create your own project with circular economy. So module 1, what is module 1 about? Module 1 is about the foundation of circular economy. So what is circular economy? What are the challenges? What are the benefits? And what are some business models that you can pursue with circular economy? Module 2, on the other hand, is about circular economy in the value chain of manufacturing. So we will go through, okay, what does the manufacturing process entail, and how can you implement circular economy in this manufacturing process. Module 3 is about digital tools, IoT, and also artificial intelligence. How can you use circular innovation or circular economy and digital tools to get further in your company? This also entails digital twins, for instance, or augmented and mixed reality, and also AI-driven optimization. And robots, such as Poppy, I guess. Module 4 is focused on construction. So this is our first area that we want to specifically describe more in detail. So this is on the construction sector and how circular economy can be applied in this sector. Module 5 is about electronics. So we want to also show how you can use circular economy in the electronics sector. And it's about sustainable design, also lifespan extension, e-waste management, and how you can operate that and make it also resource efficient. Module 6 is about textiles by Fraunhofer. This is not about only fashion textiles, but also technical textiles and how you can use the circular innovation in this sector. And module 7 is for us, it's transversal tools for circular economy. So these are just tools that you can use to get your circular innovation process more ahead, and certain tools and applications that can be used for that, strategies, business models, data management tools, and also risk management. And last but not least, module 8 is learning by doing. And this is to turn your ideas into actions. So now you have gained all this knowledge, and now you want to do something with that in your company. So that was the overview of all the 8 modules. Does anyone want to add something as a module owner? Okay, everybody seems very happy in the crowd, so I don't think so. So that was the main overview. And now I will give you a short overview. Please, if you are not registered yet, use this QR code and register. So this is the direct code to the Moodle course. It is for free, so you don't need to worry about anything. And we put a lot of work into it, so we would be happy if you subscribe. Yes, this will also, of course, count to our indicators. So if you subscribe, you will also count towards the 120 participants. Okay, then afterwards, if you have registered now directly, you need to search, because there are more courses on this platform, you need to search for the Circular Innovation Academy by Smart Circuit. This is the course on the website, and you need to put in the password. It's Smart Circuit 25, the secret password. Should I wait for 1 second? I see some people register. So maybe your colleagues know the password Smart Circuit 25. Yes. So let's continue with the next slide. So how does this work? We tried to make a very user-friendly platform, which is not very complex. We had the same structure for all the modules. So first of all, we start with the learning materials. So you can use the learning materials, the learning materials are presented in PowerPoint slides. And if you click on module 1 and then on learning materials, then you can go through this presentation. So you don't need to download anything. You can watch it all the time. And you can also see where you left and where you didn't, what you didn't do yet. Afterwards, we would ask you to fill out the feedback form. This is very important for us in order to optimize our course in further project and to ensure sustainability after the project as well, and to have feedback if it's okay or not. So this is the overall course evaluation that you can see, and it's also anonymous, so you don't need to worry that we will track you down and or know who you are if you have feedback. Afterwards, after the learning materials and the feedback form, you will be asked to do a quiz. And this is the same thing that we did in the beginning with the Mentimeter. So each question was about one module, and we had 7 modules, and each question was from one module. So it works similar like this. And if you complete one quiz module, then you will get also the certificate for that. So, okay, here you can see the feedback form. It's also a short, simple feedback form where you just put in your answers. And bonus, the certification. We have also provided a certification if you have done more modules, so that you don't need to show 7 or 8 certificates to your employer or anybody. If you have completed all the mandatory modules, this is 1, 2, 3, and 7, then and also one of the optional modules, which is about one of the application areas, so textiles construction, for instance, then you will get the certificate for the whole course. So this is also one overall certificate that you then can get and show your employer to show your progress that you have made. So now I would like to start with the panel. So Agnieszka, please, Veronica and Ossi, please join me here. So this is the last part. We did not want to only show it theoretically, but also ask some questions to our audience. Thanks a lot. So
Exactly. The first question to everybody, what does Circular Innovation Academy mean to you in a daily life or work?
The floor to boss of the boss.
Would you mind to repeat the question?
What does Circular Innovation Academy, what does circular economy mean to you in your personal or work life?
Well, I guess during the last few years, as it was already like explained by several of the speakers we had today, circular economy is something which came from top to us all, especially the last years. SMEs and also mid-caps had to perform several indicators in order to fulfill their requirements. Not going to say how politics decided on for our future, but still, we do believe that sustainability is an important topic, and because of that, I guess we started to invest much more time in innovating production processes, rethinking these processes, and investing into technologies. And I guess the last few, especially European calls which came out, they focused really on how to implement technologies into the industry, especially SMEs and mid-caps, and that's where my project at least are working on.
Okay. If I may add to what Ossi said, I think it was a very crucial and important step we did together as the consortium, starting for the scratching the information, looking for the knowledge that we as the organization, as expressed in the very, very beginning, very varied experience, mature organization, we needed this kind of information to be presented in very smart, very acceptable, easy way to understand what's going in the circular economy principles and how to transfer that information to small and medium enterprises we work on everyday basis. So what we did first, we started to test what we, okay. First of all, as you could see, we divided this task between hours, looking at our competences we have, and preparing the curriculum. Then we tested it internally and with our technical experts to verify the information provided, functionality, but very, very mainly focusing on the content. And then what was presented by Thomas, going outside of the box, showing the Circular Innovation Academy to the public to upgrade and to bridge the competences gaps we can see in our regions, among policymakers, among business technology organizations, and also within the companies. And what we did, we think it's a small step, but really towards a big change. That's how we did it, and that's it. I think it's in all of us heart, the CIA.
Thanks a lot for the answer. Do you also want to answer this question?
I think it was all said. I would just add that maybe for me is really on the daily basis working with the circular innovation. For me, there are tools and knowledge that we can really use on daily basis to build even small cases. Not even, we don't have to build like huge pilot, but we can really practice it on daily basis.
Mm-hmm. Thanks a lot. So I have a few more questions if the time allows. So Ossi, you are one of the first participants of the academy. How did the innovation, or what would you recommend to any newcomers that join the platform?
Well, I guess just to scroll through the Innovation Academy, which how we designed it. I guess it's a very easy and straightforward way to just get some thoughts for food, to get some information on how circularity can be. I guess it's not the most sophisticated and way too detailed platform to inform yourself. And screening through, and as you could have seen already on the Mentimeter questions, there's also a little bit of fun in it, because I guess each answer was kind of obvious what the right answer was or should have been. So, and so it's like a basic mixture of having some fun, getting some information, and maybe find one topic which you just want to invest more time in it.
Thanks a lot for your answer.
And if I could add to what Ossi said, I think it's really very important from the practical point of view, because we put there a lot of hands-on training, taking the best practices from master classes being provided by technical panelists. And what is also, I think, important here, that in the areas when we want to communicate the circular economy principles in the very sophisticated and technical matter, we do so. But also what Ossi said, it is very straightforward, so everybody to digest and take the opportunity to just upgrade the knowledge and get some more skills in this area.
Thanks a lot. Veronica, your main focus was on Module 8. Why do you think it's important to do the Module 8 learning by doing?
Well, it's important because the Module 8 actually brings all the knowledge into action. It's important for those who wants to use the knowledge, who wants to use what they learned, because in Module 8 you have the opportunity to bring your knowledge into your action plan. So you will, at the end, you will receive really actionable plan that you can show to your management, or you can use it as a start for your own project.
Thanks a lot. Maybe one final question to Agnieszka. How does...
Funny questions.
Sorry.
Yes.
So we have built this Moodle course, and how do you think this Moodle course can fit into the broader goals of the Smart Circuit project and also to the sustainability goals of the European Union?
Honestly saying, it is the task that I took on my shoulders to think about maintaining the circular academy, to bring circular academy longevity. So what we are just discussing in our partnership is to ensure that this knowledge truly reaches and benefits to local businesses. Because as you know, as you can see and hear, we are speaking the English, that's our joint language, and the real need of our companies from our region is to have this information, but provided in our local languages. So we are thinking how to use this project and the opportunity and the huge amount of work that was put by each partner to bring a lot of benefits to our local small and medium enterprises who really need such information provided in the easy, acceptable way. So that's what we are thinking about, and this will be a task for our meeting tomorrow.
Thanks a lot to the panel, and thanks a lot to the answers. I would like to ask you in the audience, maybe does anyone have a problem with registering on the Moodle platform? Then we can still assist at the end of this talk. Thanks a lot to the panel, and yes.
Thank you very much.
So at the end of this long but inspiring day, I would like to just summarize conclusion in one sentence. After everything we heard and shared today, we can say that packaging sector and plastic sector indeed is ready to embrace innovation in circularity, but it demands continuous adaptation, and progress is possible only if all stakeholders, variety of stakeholders groups are included in this progress. So I would like to sincerely thank our speakers today, our colleagues, partners, and everybody who make this event possible. Thank you for joining us in Zadar on site and also online. I wish you a pleasant evening. We can meet at 7:30 in the center of the Zadar at the restaurant Two Ribara, Two Fishermen's. And we could have now with Poppy one group photo for the conclusion of the day. Okay, thank you.